Hello.
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 Sir, am I audible?
Yes, yes.
Yes, sir. Thank you, sir. Uh, so I'm requesting to all the participants, can you please share your paper IDs in chat? Sorry, sir. Actually, we have a delay. We are starting from 2:30, sir. Uh,
Okay. So
yeah.
we should wait then.
Yes, sir. Or like you can join at 2:30 also. No issue, sir.
Okay. So
Have you
just
received?
I will be live only I will be muting myself.
Yes, sir. Sir, I wanted to ask you, you received your this
Yes.
uh, evolution sheet, sir?
Yes, yes. I got evaluation sheet. It is with me.
Okay,
There
sir.
are only four papers in that: 22, 37, 209, and 122.
Yes, sir. Yes, sir. Yes, yes, sir.
All the four papers are there, or they will be no, some of them will be absent.
So they are writing the paper ID so that we can know in better
Okay.
way. So
Okay.
209 is present.
Okay.
Yes,
No problem. No problem. Okay.
yes, sir. Thank you, sir. Hello.
Hello. Yes.
Yes. So we are starting.
Yes. Yes. No problem.
Everyone is here.
Okay.
Share the screen. Can I share? Why it is coming for screen? It is showing. Correct. Just duplicate. Can, can you it is not coming. So, good afternoon, everyone. I am Jyoti Prajapati, and I would like to welcome to all in the ICBDS conference session 2 for security and privacy directions. So, it is my immense pleasure to announce our session chairs, Dr. Anant Umbarkar and Dr. Satyanarayan Bolala. Dr. Anant Umbarkar has received his bachelor degree in computer science from the PICT Pune and his master's from computer science in engineering from WAC Sangli. His PhD CSE from the Government College of Engineering Aurangabad and affiliated BAMU Aurangabad. Currently, he is working as a head Department of IT at Walchand College of Engineering Sangli from 2020. He held total 18 years of teaching experience. He has published 20 papers in journal and 19 papers in national and international conferences. He is a reviewer of IEEE, elsewhere, ACEEE journals and the program committee member and receiver for many international conferences in the area of soft computing. He is professionally affiliated with ISTE, ACCS, C, uh, CISI, and ACEEE, IACSIT, and many more things. He is a member of MIR USA. And our second internal session chair is Dr. Satyanarayan Bolala. He's So we are delighted to introduce Dr. Satyanarayan Volala, who will be serving as a distinguished session chair for this event. So Dr. Volala has an academic career in teaching, reached new heights when he honored with the prestigious TEQIP President's Fellowship for his outstanding PhD at the National Institute of Technology, Trichy. He received for his fellowship in the testament of his academic excellence and commitment to advancing knowledge in his field. He has a various research paper in IEEE and at different places. As an assistant professor, Dr. Satyanarayan Walala brings not only his profound knowledge but also his passion for exploring the concept, complex mathematical and computational concepts. His dedication to research and education has undoubtedly had a significant impact on the academic community. We are honored to have such a nice people in our session for this event and anticipate the invaluable insights and guidance will help to us in this session. So, I will this is for the participants. I will call by the paper ID. So, in this presentation, total you have a 10 minutes and 2 minutes for the QA. So, before starting, I just think better you focus on your methodology section and result and discussion instead of talking more about the introduction. So, I will take paper ID and okay. So the first paper ID is paper ID 22, enhance accident detection system using IoT. I'm making you a co-host, so please share your screen. Sampada Gaikwad, hello, are you available?
Yes, she's there, but I think she's not in a position to listen it. Animesh Srivastava is also there.
So paper ID 37, hello.
Yeah, hello.
Yeah, so you can share your paper. Okay,
Okay.
Nikhil Rani. You can on your camera better. Yes, you can start. Okay, make it full screen and start.
Is it visible in full screen?
Yes,
Yes, visible.
So I'll start.
yes, go ahead.
Okay. So hello everyone. Myself Rani from Vishwakarma Institute of Technology, Pune. I'm studying final year ENTC. So I will be presenting a paper titled Anomalous Behavior Detection in Surveillance Cameras using Optical Flow Algorithm. Coming to the abstract of the paper, our research focused on making public spaces safer by using advanced technologies to detect suspicious behaviors like fights. What's unique about our work is that we combined different techniques like optical flow, background subtraction, along with the support vector machines classifier to detect unusual events in surveillance videos. So we have achieved mean AUC of 92% along with strong accuracy of 86% with our system. we can use these tools for law enforcement to spot and prevent crimes, ultimately improving the public security. So the next up is introduction. There are challenges in traditional methods for detection of fights. In traditional methods, like imagine having to watch countless hours of surveillance videos manually. It's not only impractical, but also prone to errors. This makes it really tough for human operators to spot and respond to incidents that they happen as they happen. Okay. This is where the automated methods come in. Leveraging computer vision and machine learning technologies, it have become an essential part to detect such behaviors and ensure this public safety very effectively. So now let's understand a key technique we use, that is optical flow. It's a computer vision technology that calculates how objects or features move between consecutive video frames. Think of it as tracking a shifting pixel in image. This gives us very valuable insights into motion and direction of the objects moving in the video. When something unusual happens, optical flow technology captures sudden and erratic motions. This is a big clue that something might be off. Okay, and it makes our system really good at spotting anomalies in public spaces, which is very crucial for keeping people safe. Moving to the methodology, the traditional core methodology is based on optical flow based magnitude thresholding, where the use of Gunnar-Farnbach optical flow algorithm from OpenCV library is utilized. Then here we calculate the motion of pixel between consecutive frames, effectively capturing the movements within the video. The features are extracted then to transform into flow magnitudes. That means the intensity of displacement in the consecutive frames. We then compute the mean magnitude of these features, which serves as crucial thresholds. If this feature magnitude surpasses the threshold, we classify the videos as abnormal. So where in this paper, the main focus is on this methodology, which utilizes background subtraction and support vector machines to classify the results. So we begin with adapting the UCF crime dataset to create, just a second. We utilize the, we begin with adapting the UCF crime dataset to create more focused dataset containing 30 frames videos of both fight as well as normal activities. To isolate these moving isolate this moving object in videos, we use the combined difference image method. This technique subtracts the background, helping us to identify objects in the motion. Then from these background subtracted videos, subtracted crucial features like gray, canny edges, Harris and Laplacian filters, optical flow and optical magnitudes, and Euler. Extracted features were then aggregated and fed into two-class SVM with RBF kernel to optimize this. SVM's performance, we conducted hyperparameter tuning using grid search CV. And to ensure the reliability of our classifier, we perform 5-fold cross validation using stratified K-fold. After training SVM model various features, like we use hard voting classifier to make the classifying decision, to make a final classification decision. And this classifier also aggregates the output of all the results and hence the final output. Have a look at the pre-processed feature set extracted from video data using various filters and background subtraction techniques. For example, after applying background subtraction and then using the Harris filter on that frame, we computed these these features, these values, which are computed using pixel-wise NumPy addition on that current frame. And here the final dataset for this process contained 247 videos for training, along with which each of which have containing 0 to 27 frames. That is 28 frames in total for all the videos. This visual represents the output of Farnback optical flow algorithm. To make it more visually understandable, we have used the markers to represent both the magnitude as well as the direction. Have a look at this HSV representation for better understanding. This represents the flow in the form of heat map. To gain more comprehensive understanding, you can these examples showcase the videos that have been successfully classified as normal and abnormal. This is the normal version. This is the abnormal version. This is the normal version. Moving further, next is a performance metrics used for evaluation of this model. Our ROCs mean area under curvature score averaged an impressive 92% with standard deviation of 5%. We also attained accuracy rate of 86%, but here AUC is the primary metric as it better quantifies our model's ability to distinguish between normal and abnormal behavior, which is crucial for this research. So to conclude, we implemented various methods like optical flow, background suppression, and support vector machines to make detecting fights in surveillance video more effective. And talking about benefits of our approach, it can be used for use as public safety, traffic monitoring, and security surveillance. Also, it's also got insight that researchers and law enforcement can find handy. To improve this system further, our aim for future research is to explore deep learning algorithms and add audio-visual features, then create real-time applications, test on various datasets, and investigate transfer learning for better accuracy. So overall, progress in video-based abnormal behavior detection can significantly boost public safety in various diverse environments. These are some of the references we use for our research. Thank you. Any questions?
Well, Nikhil, good. You have done a good experimentation.
Yeah, thank you.
When was the optical flow algorithm was introduced?
Yeah, the optical flow algorithms was introduced at a very early stage of the computer vision era, which was around 2000s. So there are these two algorithms mainly used. That is Lucas Canade, which focuses on only the key points on the videos and then track those key points. And the second algorithm was lately discovered, I think, in around 2002, which was a Gunnar-Farnback algorithm, which focuses on entire pixels of the frames and calculate the displacement of the calculated points that are moving or displacements.
So then, what was the application that was there for this algorithm in the area of video surveillance earlier?
Yeah, the area of this algorithm focus on mainly detection of the motion tracking, object tracking. But there are features when we did during our research, when we did feature engineering, we came across the features that we extracted that correlated with tracking of these fights. So we first our approach was to do the general suspicious detection, suspicious activity detection, but we focused on this fight detection area as the data set was also there, and our technique of using only core machine learning was better suited for this approach.
Okay, so then if you want to compare this optical based algorithm with the machine learning based algorithm, then which will work better according to you?
Yeah, currently there are many significant improvements in the field of this.
CNN and all deep learning.
Yeah. In deep learning phase, in deep learning area, there are many significant improvements. Like there are better accuracy, but we focused on mainly doing this project in core machine learning using support vector machines.
Yeah, that's correct. The basic things are very fine.
Yeah.
My question is like, say, can we have a combination of this optical flow with the CNN?
Yeah.
Then how it will improve the accuracy or the results quality?
First of all, it will significantly reduce time to do the feature engineering, as we can pass directly the convolution and pooling layers, which can extract all these features for us, and it will automatically understand what the videos are and how to detect those anomalies. And also there are algorithms already in this field that are giving significant results. So
Okay. Can you go to the result and can you explain any one table, just one table, any one table? You have shown one slide on that.
yeah, this one, right?
Yes.
Okay, so for the post processing of our data set, which we use
Just
for
one reading you need to explain. Let's say Harris and number one in that.
Okay, so our data set contain a total of 247 videos, and then these feature, that is 35 60 310. These are the numpy addition value of the image pixels when we background subtract image and then apply the Harris corner feature. Then there are certain pixels on that image that are those pixel values are total added as a numpy addition, and those values per frame are noted here. Like for the zeroth frame of the zeroth video, this value is there. First frame of the zeroth video is this. Like this, there are 28 frames in every video in our data set, and such like this Harris, Laplacian, Euler, optical angles, optical magnitude, these features are extracted, and then we pass them to SVM and then hard-coded classifier.
One more thing, like say on one side there are 28 videos. On the vertical side there are 0 to 246. What is that?
0 to 246 means these are the number of videos. Total we have used 247
videos are there.
Yeah.
And then based on this, you are, I think, summing them and then putting them in a two class.
Yeah, there are two classes, which are 0 means it denotes the that is the video is normal, and one which denotes the video is abnormal.
But based on what?
We have manually curated the data set, and we have manually curated the data set after post processing. And for all those 247 videos, only the part of feature engineering was to get these values, these numpy added values.
Okay. Thank you.
Yeah. Any more question?
So from my side, only one question. Actually, already there is a lot of research work on suspicious detection from the videos and so yeah. Can you please tell in one or two statements how your work is different from the existing work?
Okay, so my work is it focuses on applying background subtraction and using all those computer vision key features, key techniques like Harris corner detection, Laplacian filters, and all those. And after that, using some hyperparameter tuning and using a support vector machine. This algorithm was like we have. I'm like studying in. I was studying in third year, and this paper was actually a part of computer vision subject. So all those key technologies I've tried to implement in this research.
Everyone is using whatever you are telling. Everyone is using same thing.
So no. Actually, everyone was like doing the threshold part where the magnitude and angles were calculated. This part was the traditional part, and this part was our key methodology where we use the different types of feature extraction techniques and then train the model on SVM.
Okay, same thing you are repeating. Okay, just to work out on this one. Okay.
Yeah. So thank you so much, paper ID 37. So next, I would like to call the paper ID 22, if available. Paper ID 2, Sampada. Hello.
The guide part.
Okay.
209.
So the paper ID 209, Animesh Srivastav.
Yes, ma'am, please.
Animesh.
Animesh, are you able to share your screen?
Yes, I will share. Okay. I do not get any option from right now. I'm not getting. Okay.
Participants and co-host.
He's already.
Sure.
You're already co-host.
Already your coach.
Okay.
Yes,
Show capture. And, can you help me from where the
Share
option is?
screen. Use share screen option.
Bottom.
Green color is given.
Okay. Yes. Okay.
Share screen. You have to share screen.
Now you go to your presentation.
And make it full screen.
Yeah, make it
Okay. Just a
And share your camera also.
okay. My camera is not working.
Okay, no problem. Go ahead.
Okay. So my voice is clear. My screen is visible.
Yes.
Yes.
Okay. Thank you. Thank you very much. Thanks.
Starting paper ID 209. I hope
Yes.
you know we have 10 minutes. So
Okay.
try to complete everything in 10 minutes so that we can have the time for Q also.
Okay. I can take care of that. Now, my paper ID is 209. My title is a review of authentication protocol using HECC. Authors are Dr. Bhupen Singh Rawat, Kulbir Singh, Dr. Vivek Bhatnagar, Shivashish, myself is Animesh Srivastav. Now, table of contents are abstract introduction, related work, authentication protocol, security analysis, advantages of using HECC or ECC, conclusion and references. Now, coming to the point of the abstract, right now the electronic devices are increasing day by day. IoT devices are exponentially increasing. So cyber risks are also increasing right nowadays. So there is a requirement of a robust cryptographical method in this currently for integrity and privacy method. So that can be resulting into increase the reliance of the electronic devices, which right now they are using. Somehow some devices are right now the authentication schemes are using, they are going to be uprooted in 2030. So new authentication schemes are required in that area. So in somehow we have presently evaluate the authentication for HECC. So right now introduction part, and right now ECC electric current cryptography is a key based technique for encryption and decryption right now, and it is we can say one step ahead with the RSA on encryption and decryption. Over the security providing over a wireless medium got significant importance because the inheritance power, there are concerned with the IoT devices memory and processing constraints are there. So we are using the hyper elective, with the one step ahead, hyper elective cryptographical system in the resource constrained environment for digital signature and many such. Hyper elective is similar to HCCC, which showing some more security efficiency and alternative with the ECC that also. So and somehow some related works are there which has been done in these areas which we have analyzed. Some ECC work has been done in the resulting to brief security about that area. Some RSA HECC with comparison with MD5 authentication method with high degree of security, and somehow with this type of discrete algorithms, hyperlink curve has been developed, and they are also analyzed, and some researchers have some error-related correction course has been developed in these area, and work has been done. So somehow or more or less these areas, they are basically concentrated on the lightweight devices such as for IoT and other purposes. Some are using ECC, some are using also RSA algorithm, some are using with error correction course and these areas. So authentication set rules of computer system user entry attempts, resource concerns devices for there, and prevent unauthorized access for that purpose. So hyper-elective curves are defined. What is the definition of hyper-elective curves? Are defined high degree of polynomial equation. So polynomial degree greater than 3, we can say, simply allow with a wide range of curve and shapes and properties. And HECC can be more complex due to greater variety of we can say shapes and degree, which are greater than 3 or 3 or greater than, and up to 2 that we can use in the ECC. The choice dependent on specific, we can say, the choice is totally dependent on the specific requirement of the cryptographical application, we can say. And this is a bit basically trade-off between, we can say, between the security and efficiency. So if we can say main advantages of that, this process of HECC, we can say main advantages of HECC is that it can be provide same level of security as ECC with the shorter key. But HECC is good for application where security is a top priority, because the we can say with a greater polynomial greater than 3, there should be a some we can say some type of calculations are there to start. It is common practice that utilize some credentials multiplication programs for there. So there is conduct offer resistance to convert, we can say, prevent attacks inside this and public key process. So session key, security, ID keys, and all that. Additionally, HECC credit algorithm register upcoming right nowadays. There are quantum computing attacks are there. So HECC can register these kind of quantum computing attack also. So security despite the future quantum computing attack, we can also use the HECC. So with the comparison of ECC, HECC offers strong security with greater key size and of computational effort. Curve are more resistant, and mathematically we can use more complex curves in this process, and parameter are more secure and these area. So research gap, what we have find with this, HECC is good choice for application where security is the top priority, we can say. In view, HECC authentication protocol important for applications such as RFID, IoTs, these kind of things, and for security of some privacy and assistance. So authenticate protocol that HECC provides solutions are more efficient, secure in the sense, more resistance from different type of attacks, and right now upcoming attacks such as quantum computing, it can be resist. So these type of resistance of attack in the environment currently they are providing with that examination and solution which can be improve efficiencies also in future. So these are some references which we have used. So these.
Animesh.
Yes, sir.
What was the aim in doing the review of the this authentication protocol?
Yes, sir. My basic aim is right now for getting that for what purpose we use HECC and what purpose we use ECC. Simple answer, HECC is good for the application where top priority of that security is top priority, and normal condition, normal security purpose, we have to use ECC in normal conditions. At least we can say for moderate level of security, we use ECC. That is a differentiation purpose, and that is a major.
Okay, so that means the ECC or HECC you are focusing only.
Yes, sir.
Okay. But what are the other authentication protocols that has been used currently?
Sir, right now the authentication protocols such as RSA and many more are using right nowadays, but they have a drawback such as RSA is going to be.
Those are very traditional one. Do you know about the Kerberos and all those things?
Sir, yes, sir. Kerberos, it has been there for developed by MIT, but still the Kerberos system, the message has been exchanged up to the number of the 6 and many more. So in that process, the message loss and many more problems are there. So right now they are in HECC and ECC, the number of messages which has been exchanged, 3, 4, that up to we can easily manage. So there is in a network such as IoT, the nature of the IoT environment is dynamic. So the errors are there and packet may be losses. So we need to minimum packet should be transferred and authenticated. This is our mainly concern, because in dynamic nature, if we are exchanging 6 messages, it can be possible one message can be lost. So rework should be there.
Okay, then when you are doing the review, you should point out that for what kind of application you are doing this review.
Sir, I have mentioned that review is basically for the that purpose for IoT devices.
Only
Yes.
for IoT devices.
Yes, sir.
Okay, and what about the computational overhead that will be required when you are calculating these codes, keys?
Sir, there is a HECC is a higher computational complexity as compared to ECC. As I said, there's a polynomial degree.
IoT devices doesn't have that much computational power, no?
Yes, sir. That is it. So that's why we are saying that there is a trade-off between, we can say right now they are using somehow they are using ECC. So and we want to extend some in which case where the security is major concern. That is the only point somehow.
Okay. Okay. Thank you.
Nimesh,
Yes, sir, please.
your paper title is a review of authentication protocols using HECC, right?
Yes, sir.
But you what is that? The type, is it suitable title for your work?
Sir, I am I am reviewing the authentication protocol using HCC.
No, you are not reviewed even a single authentication protocol, I can tell. Just you are comparing, you are just explaining the relative comparison between ECC and HECC. You never mention any protocol. See, is ECC is a protocol or HECC is a protocol?
Sir, that is a authentication scheme, sir.
Protocol, techniques, okay.
And
Yes,
change
yes.
the title and make the comparison of HECC and ECC.
Okay.
And in the one part, you can just say that it can be used for IoT applications or some other applications also. You can mention that. Na?
Okay. Okay.
And
Okay.
rather than just saying a very highlighted statement, but which has not been verified. So change the title and also communicate to the conference, because then they are putting it in the proceeding. So that so wrong and information should not go into the public domain on your name or your colleague's name. Huh? So change that, communicate with the conference people and do that.
Okay.
Yeah, that is not a suitable title. And moreover, that the comparison you have given, ECC and HECC, in terms of just statements you have given, you didn't mention any proof or you didn't mention any factors. What is that? Principle, whatever it may be, you did not mention anything like which one is better than other one, like that. Okay.
Okay.
So, and moreover, you try to read more number of papers.
Okay.
So this is not the way to do. What is that? Survey. If your survey is clear, then only you can identify your research gaps. Okay.
Okay. Okay.
So hope so you receive good suggestions. So I'm calling that next paper, that paper ID 122. Available? Hello? Paper ID 122?
Yes, I am available, madam.
Okay, this is administrator. Ma'am, please on your camera, and you have 10 minutes for your presentation and 2 minutes for your Q&A. So present accordingly, ma'am.
Yes. Yes, okay, madam. Thank you.
Ma'am, share your screen. This green color is given a share screen.
At the bottom, there is a arrow mark, right?
Yeah.
Make it presentation mode. Yes.
Is the
Yes,
screen
go ahead.
visible, madam?
Yeah,
Yes.
Ma'am, you can start. Yeah.
Thank you, Ananda. So, thank you for giving me this opportunity. So today I'm presenting my concept, that is homomorphic encryption for secure computation of white page area in medical images. So this is the presentation outline. So coming to abstract. So as we all know that medical images contain some pathological abnormalities. So in which is in the form of white patch area. So white patch area plays a vital role or important role in the diagnosis of the associated disorders. So due to the advancement in the technology, most of the medical records are hosted in cloud servers for local storage and also for efficient dissemination. That's why usually they prefer to store medical images in the clouds because of its advantages. That is due to the availability of whatever bandwidth we can say, that we can transmit and also for diagnosis purpose and all those things. The medical images are encrypted and then stored in the cloud for security and also privacy. So here we are using the concept of homomorphic encryption to take the advantage of the computational capabilities with respect to the cloud server. So white patch area is nothing but how we'll calculate the white patch area is by counting the pixels in the cipher domain. So in the simulated results, what we have observed is the performance of the proposed network is better with comparing with the existing techniques. So coming to introduction part, so let me tell you what is homomorphic encryption. So homomorphic encryption, we can do homomorphic addition, multiplication, likewise. So homomorphic encryption enables the calculation of different mathematical operations, as I said, addition, multiplication in the cipher domain. So here we do homomorphic encryption in the cipher domain, not in the plain text. So let us consider an example. Here x1 and x2 are the two matrices what I have considered as an example. So here HE of x1 is the homomorphic encryption of x1, HE of x2 is the homomorphic encryption of x2. So if we operate decryption operation on the homomorphic encrypted product, say HE of x1 into HE of x2, will get original multiplication. That is, whatever we do homomorphic operation is with respect to the encrypted image we are doing, so that when we send that image to the cloud, so nobody can decrypt. Those who have the key can only decrypt that particular white patch area which is calculated on the encrypted image. Since matrix represents images, homomorphic encryption of matrices facilitates homomorphic image processing. Here the main objective is to develop an efficient matrix transmission scheme for homomorphic white patch area calculation for binarized medical images. Here we are considering the binary image. That is, first we'll convert that gray image into binary, so that whatever the number of ones part is there, which is considered as a white patch. Because when we do encryption, that encrypted image will be in terms of integer, not in the binary form. So that we'll do encryption operation, homomorphic encryption operation on the cipher image. So the proposed method is designated as HWPAC. So here we will consider that integer matrix in the finite area ZP for homomorphic encryption and also decryption. So here we are explaining how keys are generated, encryption key and decryption keys are generated for the homomorphic operation. So encryption and decryption keys are derived from the orthogonal integer matrix Q is taken. So all the elements with respect to this whatever orthogonal integer matrix will be in the range from 0 to p minus 1. Suppose if I have taken an image which is gray level from 0 to 256, if I say for n is equal to 8-bit image, then p will be 255. So p is a relatively prime number and it is always greater than n, where n is the size of the image matrix, that is n cross n. Orthogonal integer matrix Q is generated using household construction, which is discussed in the main paper as Q is equal to, which is given the formula, where y is taken as a non-zero column vector of size m cross 1. So dividing by y transpose into y, which is nothing but if we operate with y transpose into y, that is, if I am taking y transpose, which is a column vector into row. So by multiplying a column vector with a row vector, it is always be a single number. That is why dividing by a scalar is nothing but replaced by multiplication by its modular inverse. Since Q is orthogonal, Q transpose into Q is nothing but identity matrix. Now, here we are explaining how Q transpose and Q is divided into two subparts, that is E, F, and in Q, H and H of different size, that is E, N cross M. For the taken example, N is equal to M minus 2. For example, if M I will consider as 6, then N will be 4. So for the taken example, that is M cross M, Q transpose is E will be, N is 4, M is 6. So 4 cross 6. So it is 4 row 6 column. F will be 2 row 6 column. That is the total size of the Q transpose is 6 cross 6. Similarly, Q will be divided into two submatrix, say H of 6 cross 4, H of 6 cross 2. So identity matrix will be like Q transpose into Q. If we multiply Q transpose into Q, the first sub will be identity matrix of size n cross n. Then the next part will be 0. Here it is 0, then identity again. So substituting this Q transpose Q.
I'm having one doubt here.
In the equation 2.
Excuse me.
Excuse me. Yes.
I go to the previous slide.
Yes, sir.
But the equation 2, now you are telling Q transpose into Q.
Yes, sir.
This identity, then how the Q transpose is different from inverse? Then only matrix and its inverse is identity, right?
Yes, sir.
And then on what basis you are telling Q transpose and into Q is equal to I? Equation 2.
Yes, sir. Q will be I only, sir.
Sorry? How the transpose of a matrix into matrix equal to identity?
It's an orthogonal matrix.
Orthogonal matrix. Okay, right. Orthogonal, okay, carry on.
Orthogonal matrix, that's why we'll get identity matrix only by multiplying.
Actually, you should have mentioned there.
Can you give some example of one matrices, like say take 2 by 2 matrix and what will be Q of T and what is Q, so that we can understand. Take, let's say 2 by 2 matrix. So let's take 2, 2, 2, 2. And what is QT? QT will be what? Transpose. What is transpose of this 2, 2, 2, 2, all 2, 2, let's say. Take such example and then there is no problem. I say that it is okay.
Okay, you continue. No issue.
You continue. Well, let's at the end we'll.
Okay, sir. So at the end I'll share, sir, how we'll calculate that part. Yes,
go ahead.
Sure, sir. So identity matrix, if I say 4 cross 4, the obtained matrix, which is after multiplying Q transpose and Q, will get in. I'm taking an example of 4 cross 4 only here. So I'll show it later on, sir. How will consider for Q transpose and Q, which is a 6 cross 6 matrix I have taken. So multiplying this, for example, in the first two 1 0 0 1 will be there in I n cross n, and in the second submatrix 0 0 0 0 0 will be there. That is, if after multiplying Q transpose and Q, will get I with m cross m. For example, 1 0 0 0 like 0 1 0 0 0 0 1 0 0 0 0 1. So if I divide this identity matrix into 4 equal parts, in the first upper part will be 1 0 0 1, second part 0 0 0 0 likewise will get. So I'll share that example to you, sir, after the completion of my presentation. Then yes, substituting this Q transpose and Q will get I. So just by taking row column operation E n cross m into H, row column multiplication, the first part, as I said, E into H will be identity. This is what I have considered. And again, the row column multiplication, first row, second column, what we'll get. And this second row, first column, what I'm multiplying, it's all zero matrix. Here, what I'm taking equation 5 is E n cross M into H n cross M, which is equal to identity matrix. In homomorphic white patch area calculation, this H is the decryption key, E is the encryption key. So it can be seen that E is the left modular inverse of H. Using the orthogonal matrix Q, avoids the direct modular matrix inversions, which is a complex operation for lower sized image matrices. That's why we are considering the orthogonal matrix, because left modular inverse of whatever H is considering will get the identity. So that for the, so let me explain here, sir, how it works. So homomorphic encryption. So here whatever the input image we are considered is A, so which is in the binary form. Now homomorphic encryption of matrix A of size is taken n cross n is obtained as A multiplying with encryption key E, which is, and modular P. As I said, whatever the elements that are present in an image, we should be for example, if I take a gray image, if I take, there will be no value called 256, because all the pixels should be within 0 to 255. Likewise, if anything exceeds when the calculation operation, will take mod for that, so that all the values will be within the finite region called ZP. That's what here, where P is a prime number, what I said. So C is equal to, which can be simply represented as A into E, where E is the encryption key. Now the size of the C is, A is taken as n cross n, E is taken as n cross m. So the final resulting encrypted image, cipher image, whose size is n cross m, which is stored in the cloud server, as I said in the figure. So this binary image is taken, homomorphic encryption operation is done. So this C image will be transmitted to the cloud, where in the cloud we'll calculate white patch area calculation unit. Here the complete white patch area will not be calculated. At the user part, here I'll tell you. So with the key B, how we'll generate that B and G, and we will transmit that keys E, H, B, G will be in the key generation center. So yes, the decryption of C is carried out by the end user by post multiplying C by H. As I said, C
Hello?
is the cipher. Yes, tell me, sir.
Interrupt you, ma'am. You are running out of time, so please try to conclude.
Wind up in the time.
Actually,
Sorry. Okay, I'll tell you. Okay, sorry. I'll make it fast. White patch area calculation will be considered by taking row column of operation of A into N, where white patch area is nothing but this column matrix will be taken and A into non-modular algebra. And so this completely equation based explanation, that's why it takes more time. So sorry. It's completely mathematics concepts involved, sir. This I have to explain with the example. It takes more time.
Go to the next part, result part.
Yes, sir. This is what.
Yes, go to the algorithm.
Sorry.
Algorithm.
This. So we'll calculate, as I said.
Go show me the algorithm.
Yes, these are the results and discussions part. So we are previous one. Yes, sir.
This is for what? Calculating the
white patch area. Yes, sir. White patch area is nothing but sum of whatever Z, where we'll calculate Z with respect to the previous equation. As I said, it's a column matrix modular of this, where inside B.
Is it your own algorithm or somebody's algorithm you are telling?
No, sir. It's absolutely my algorithm only, sir. I'm a research scholar doing PhD on homomorphic encryption concept only. Okay. So presently, I'm working like on this homomorphic encryption based concept. I have already published 2 papers on this concept only, homomorphic based encryption, reversible de-identification. One more concept I am doing now, which is accepted in Q1 journal. Now I'm working on that only. I'm writing. I've almost completed my PhD.
What is the theme you are presenting in this conference?
What, sir?
Already you have done a publication. So what is that
Yes.
change you are presenting in this conference?
So this is the completely new idea, sir. I have done the related work homomorphic encryption based on reversible de-identification. Some different concept I have used, and there I have published one paper. This concept is completely white patch area calculation. There I am concentrating on encryption concept only. Here, white patch area calculation, I'm mainly
What is
focusing
the
on.
use of white patch area?
Sir, white patch area is nothing but just for example, if we'll consider an image, whatever the white part, because an image, gray image is almost consisting of, so by setting a threshold, for example, if we are having from 1 to 255 gray integers, so higher gray values will be considered as 1. So we'll take lower gray values. For example, if I set a threshold as 75, above 75, I'll treat as binary 1. And below 75, I'll treat it 0. So I'll convert my entire gray, entire image with respect to ones and zeros. So that ones, that is nothing but whatever the major information part will be there in the ones part, that is higher pixel values compared with low, because we know in gray images, lower pixel values will not be carrying much information compared with higher pixel values.
We cannot assume such kind of things. There can be information in zeros also.
Zeros also, sir, but
your assumption may be wrong in that case.
That depends on the threshold value what we'll set, sir. Usually we'll set a lower threshold so that if
for what threshold value?
Sir, usually
what is the reason that this particular threshold value will give me this information or this subtraction from the particular gray image or black and white image? Anyway, go ahead, go to the result and discussion part. So here, what is the time complexity you're talking about? What is CER and complexities?
Sir, time complexity with respect to this homomorphic white patch area is nothing but n square into L. So compared with other, ours is less.
It's okay, but this is your only theoretical work, or have you implemented on any platform?
Sir, I've done this work with respect to Python.
No, that's okay, but he's saying that any results are there you have applied this, and what will be the time?
Sir, that is in the main paper.
What is your idea of time complexity?
Time complexity here, sir, I'm not measuring with respect to time. Here we are measuring with respect to the complication like that.
What is your understanding of complexity?
The complexity with respect to this.
How do you find out that 0.5 into log of 2n?
Here, this is a ciphertext sizes in bits by
number of comparison in an algorithm.
Yes, sir.
That is actually increasing the complexity, because there the number of more cycles are needed for the CPU, and so that is what has been taken into consideration. Bubble sort O of n square. So that is actually the time complexity, not the time. We don't talk about time.
Sir, it's not the time, sir. I'm saying.
Go ahead. Show the next slide. Anyway, you are doing some work, but I think you should have given some results, right? Yes. And then that white patch, why you are considered, again, not yet clear to me. There is huge maths that we should not deny that maths. It should be there.
Okay, sir.
And one example has to be put up so that everybody will understand. If rather than entire mathematical things, only take one example and show it along with the image on the one side.
Okay, sir. Okay, sir.
That will be more easy.
Okay,
what
sir.
Next is there to show us? What is the next part? I'll just conclude.
Yes, sir. So it's
how you are saying that this kind of technique will be good for cloud?
Sir, because in the cloud storage, we'll store the images in the cipher domain. So we can do any mathematical operation, that is white patch area collection, whatever we'll do on the encrypted image. But that original image can be accepted only by the authorized person.
Yeah, how it is effective in terms of cloud-based storage?
So for example, if we take like
how that key will be managed, that E will be managed, keys will be managed. Is it like other algorithms? They are also having there's the same keys, something is there. How it is advantageous that it will be very useful for the cloud storage?
Sir,
are you saying that it is only good for inside the storage and not over the cloud based communication and viewing the other people with a security. That is what you meant to say? See, there are two things: storing lots of images with the security inside the storage and over the cloud. So we have to clarify it. It will be for network-based communication and inside that.
It's only like if any operations that is required for whatever for example, if some research work will be on the medical images, then if they'll access the medical images from the cloud directly, but that authentication will not be given to that. They'll do whatever manipulation they want, but that originality will be maintained, but that image will be accessed only by the authorized persons, so that for transmission and whatever for analysis purpose, it will be useful, sir, for diagnosis, for doing some.
You are saying that it will be providing a security,
yes, sir,
to
security.
The images in
Yes,
short.
sir.
Okay.
Yes, sir.
That too in the cloud or in anywhere. That's okay. We should not say only for cloud it is good and something like that.
No, sir. Yes, sir.
Okay. And why for medical only then? Why you are only using the word medical?
So generally, white patches will be presenting only in medical images, sir. Generally.
Okay.
Generally, yes, sir. Generally, more patches will find in medical images, sir. White part.
But then, what is this implication of this word white patch inside your algorithm, inside your title?
Sir,
you are not focusing or not providing any kind of specific things to this particular area of image.
So, not getting, sir. Sorry.
My question is very simple. In the title, why you have put white patch area in binarized medical image computation?
Because I'll be concentrating only on the white pixel. That is, it's once, so which will named as white patch. Like I'm dividing into like white and black when I'll consider by setting a threshold.
That image into a gray to black and white. That time you are saying that.
Yes, sir.
But then very specific step of your algorithm. Yes, why you are putting in an title? It will be an internal part of the algorithm.
Yes, sir.
Is it a novel step inside your algorithm?
Is there any possibility to change instead of white patch, sir? Any suggestions, sir?
Yeah, that's what I'm saying. Is it a novel step inside your algorithm? It's a novelty of your algorithm.
No, sir. No. I'm not.
Then plainly you should write down providing a security to the binarized medical images using your technique. That's it.
Yes, sir. Yes, sir. Okay, sir. I could have done it, sir, but
yes, no problem. And by the way, the mathematics you should present on one side, on the other side example, and don't spend a time on that. In good presentation. No problem.
Okay, sir. Thank you, sir.
Okay, all the best. Good presentation. Thank you.
Thank you very much.
And you can stop sharing. So next is the paper ID 22. So
you can download the PPT.
Okay. She has some issue, so I am presenting and she will explain.
The recording has stopped.
What happened? Hello?
Hello, sir. Actually, paper ID 22. She is in meeting, but she has some issue, so we need to show her presentation so that she can present.
Her mic is working?
Yes, yes. Now just wait for 1 minute, sir.
Sir, 1 minute.
Okay, no problem. Okay.
Sampada, are you there?
Please unmute yourself, Sampada.
Hello, Sampada, can you please unmute yourself? Okay. He has medical issues mentioned in the chat, but audio recording is not received. We have received only PPT.
So, are you able to share?
No, you can share. Please share our PPT that is forwarded.
You just download half share screen करके you will present.
She is not speaking now. What is the
She
YouTube?
should share her audio.
Hello, can you please unmute yourself?
Sir, actually मैं recent कर रही हूँ मेरा
Okay.
audio version.
Audio version. How much time will be required?
That's fine.
Because we haven't seen.
Sir, just do one thing. I think just share her slide and let her talk in the same way. No problem.
Okay.
Share the slide.
आप unmute करो ना, because she is not able to. Because she is in
Sir, I'm in the hospital right now.
Okay, please. Okay, wait.
Good afternoon, everyone. I am Sampada Gaikwad. My paper title is Enhanced Accident Detection System with Arduino Uno R3 and Tinkercad Simulation under the guidance of S.R. Pavaso.
Okay,
Yes.
okay.
No issue.
No issue. You can run.
Okay, so I'm directly starting this.
Yes. No,
Okay. Record.
Sir,
only questions you can ask.
No issue.
sir, I'm sharing this audio enabled PPT.
No problem. Go ahead.
Okay, that is audio enabled.
Good afternoon, everyone. I am Sampada Gaikwad. My paper title is Enhanced Accident Detection System with Arduino Uno R3 and Tinkercad Simulation under the guidance of S.R. Pavaso. First slide is introduction. Nowadays, as the population of the world is increasing rapidly and looking for someone or something are becoming more difficult. In today's world, road accidents pose a significant threat to public safety, health, and overall development. Life of the people is under this high risk. On the other hand, the high demand of vehicle has also increased the traffic hazard and the road accident. The main cause of the accident death is delay in rescue. The problem is difficult to know that accident has occurred and locate the position where it has happened. Our research strives to bridge the existing gap by creating an effective, cost-efficient, and easily adaptable accident detection system. Our system is designed to integrate. Going to the next slide, which is abstract.
Go to the
Going to the next slide, which shows the block diagram for proposed system, which is a methodology for proposed accident detection system. Utilize the Arduino microcontroller and integrate the various sensors, including PIR, piezo, servo motor, temperature sensor, gas sensor, tilt sensor, buzzer, and LED indicator. The system aims to detect accident based on the multiple parameters such as impact, tilt angle, temperature anomalies, and gas level. Upon the accident detection, it triggers an audible alert using a buzzer and provide a visual indication through the LED indicator. Additionally, the system employs a servo motor to indicate the accident location. The system architecture consists of the following components. First is Arduino microcontroller. The Arduino serves the central processing unit and controls the data acquisition. Second one is PIR sensor. The PIR sensor detects the changes in infrared radiation caused by human presence or motion. It helps identify the presence of individuals involved in accident. Third is piezo sensor. The piezo sensor measures impact or vibrations resulting from the accident. Fourth one is servo motor. The servo motor is used to indicate the accident location. It can rotate or move in a specific direction based on the detected accident coordinates. Next one is temperature sensor. The temperature monitors the temperature anomalies. Going to the next slide, which is proposed system. This proposed system provides a high-level description of the proposed system architecture, highlighting the key components and their roles. In the subsequent section, each sensor and its integration will be discussed in detail. Along with the accident detection algorithm, the implementation specifies that Arduino microcontroller serves the system central processing unit. The Arduino microcontroller has various functions. It collects the data from sensor, aggregating input from comprehensive understanding of the environment. The microcontroller, going to the next slide, which is result. The performance evaluation of the proposed accident detection stands up. Going to the next slide, which shows that the result of my proposed system. First is impact detection, which shows that no accident is detected, the impact threshold is not exceeded. Next one is threat detection. As you show in the graph, accident is going to the next slide. Going to the next slide. These are the references for my
window and P duplicate.
Yes, sir. Actually, due to some medical issues, she's unpresent here. So she sent audio embedded PPT.
Okay.
She will not be available for the question answers.
Okay. No problem. Okay.
4 papers completed, sir.
हाँ चलो ठीक है no problem.
It's just wait. Sir will send his
Mail.
Yes, sir. So, sir, that evaluation sheet, I'm sharing my mail ID. You can send a photo.
You are sharing on the what, chat or in the
chat. She's sharing in chat.
Okay, send it.
Yeah, you check it, sir.
It's not coming in chat. Oh, yes. Jyoti.
Yes, sir. Yes.
Just you send copy, sir. I will be.
Okay. I'll just immediately send it. Okay.
Yes.
Thank you.
So I would like to thank to the session chair and all the participants. And on behalf of IIIT NAIA Raipur and ICBDS 2023, and thank you everyone, especially the participant, and hope you guys get good suggestions from the session chairs, especially from the Dr. Anant Umbarkar sir and Ulala sir. So thank you so much, and sir, we have.
Let him send the mail.
As sir, we thought you will come offline, but you are in online. So we had one memento. So we will send by courier, sir.
No problem.
Yes, sir. Still, sir, that photograph we will take. So
okay.
All participants, please.
This meeting is being recorded.
Yeah.
So can you please switch on your videos, participant?
Participants, please.
Nikhil? Yes, Nikhil is there. So Nikhil, you are from VIT.
The another person, this homomorphic encryption.
I think he is not there. Animesh is not there.
Ma'am, can you on your camera administrator?
Administrator, yeah, homomorphic encryption work. Okay, come go there. We'll stand there.
Paper ID 209. Please on your camera.
I think she is not in the meeting. There are 5 people in meeting.
Yes, sir.
Oh. Yeah.
By covering this thing.
This thing.
Come, sir, please. Come, sir, please. Come.
How do we present? Sorry. आगे वो पोस्टर तक लेना है ना? हेलो.
One.
Poster.
There now.
What happened?
So they are capturing, sir.
Who is capturing?
Do one thing. Switch on our camera so that.
Your camera.
Just a minute.
Make your camera work full screen. Yes. This is Naya Raipur. We haven't seen Naya Raipur.
So how we can do
Good,
this?
good classes.
Okay, no, sure. They will also finish.
Okay.
Thank you. Thank you.
Over.
Thank you so much, sir. They captured, and we will share these photos also, sir.
Thank you. Thank you.
Yeah. Thank you so much, sir, for
Thank you
your.
all.
Sir, mail that sheet, sir.
Yes, yes, yes. Immediately.
Just a
बंद
minute.
नहीं करना. हाँ, just mute कर दो.
Yes, participants can leave. This evaluation sheet, like after evaluation, we will inform you. Okay, participants can leave. Hello. Hello. Hello.
कर लेते शेयर ओके राइट
Okay. A very warm good evening, respected director sir, and distinguished dignitaries and participants present here online or offline. I, Vishnu Verma, warmly welcome you all to the keynote session of IEEE International Conference of Blockchain and Distributed System Security 2030. Today for this session, we have with us joined physically Dr. Surekha Deshmukh. She has over 22 years plus years of professional experience. Her current role is domain consultant sustainability practice in TCS Pune. She did her BE in electrical engineering in 1996, her ME in electrical power system in 2002 with gold medal, and her PhD in electrical engineering in 2012. As meritorious candidate, she has achieved first position at post-graduation along with few awards and recognition for research contribution at Best Technical Paper at IE, DEEP EX 2013, Aviskar 2011 and 12. Dr. Surekha is a senior member of IEEE and chair of IEEE Pune section and chair PS India Chapter Council. She also served as a member of IEEE Climate Change Committee and chair of subcommittee of CCIR CC Global Visibility. Her areas of interest are sustainability, climate change, artificial intelligence, data analytics, electrical safety, electrical vehicle, power market, power system operation and control, reliability analysis, and smart grid. She is passionate about publishing work, and her more than 35 papers till date on her record with wide technical experience. She contributed as a reviewer of IEEE PES publication elsewhere and Springle Journal. Dr. Surekha is awarded with Outstanding Volunteer Award of IEEE India Council 2020, Women in Power Award 21, IEEE PS Outstanding Engineer Award 2022, Women in Engineering Recognition in IEEMA from Electrama in February 2023. She has played a key role since 2000 at the IEEE Pune section as a chair of IEEE Young Professional Affinity Group, Secretary Treasurer IEEE Pune section, Women and Engineering member, member of IEEE Standard Group, member of Humanitarian Activity Committee, member of IE and life member of ISTE. C, also chapter representative of IEEE PS Region 10 West and chair of IEEE PS Indian Chapter Council. C was the chair of IEEE PS IS chapter of Pune section for 2019 and 2020. Both years during her tenure as a chair of PS IS chapter won the best chapter award at Pune section. Dr. Okay. I welcome her. I welcome her to give a talk on digital intervention for. Please, ma'am.
I was hoping that he will. Okay. Okay. And help me also if there is somebody that you see who is wetting in the window.
Okay,
yeah, I'll do that. Okay. Where is it? कहाँ पे है? All done, I hope. Oh. Can you just mute that? Mute them all. Morning. Today's learning. What? Introduction session.
Hello.
Hello. Am I audible?
Yes.
Yes.
So shall we take her? Padmaja is there. My introduction has happened. So okay, let me finish with that. Hi, Padmaja. Yeah. No. You don't. Honestly, I don't want that repetition.
I hope I'm.
Hey, hi, Padmaja. This is Dr. Surekha.
Yeah, of course.
Yeah, and I'm glad that you're able to join us. Only thing is, like, I'll run through my slides quickly in 15 minutes, cover my keynote, and then I'll be more than happy to hand over this dais to you. I hope it will be
No issues. No issues.
Yeah. Okay, thank you so much. Help me in between, okay? So good afternoon, everyone. I won't say this is Dr. Surekha again. The objective of this particular keynote is what all is happening in electrical engineering, specifically in terms of the kind of transformation which is happening in this industry, which is aligned to this topic of this conference. So I thought of discussing with you all important digital interventions which we have been observing in electrical engineering, specifically in two domains. One is decarbonization and energy transition. So I'll quickly run through all these slides and give you a little bit of glimpses of what is expected to be discussed under this specific topic. What can we do this here? Minimize? Oh, yeah. Perfect, no problem. I'll keep it here, it's okay. Yeah, so quickly what we need to do, we need to understand where is this industry going? What is the transformation of this particular industry? And as I said, out of primarily three areas where there is humongous transformation that has happened in terms of digitization, decarbonization, and deregulation. For this today's talk, I have picked up what all is happening under decarbonization and energy transition. And of course, the tool in this particular case is digital intervention. So when we talk in general about digital interventions, it indirectly means, what is it? How it's not going to, yes, perfect. So it means what all comes under digital interventions is a kind of list of all the technology enablements, which starts with AI, ML, data analytics, AR, VR, IoT, digital twin, blockchain, robotics, etc., etc. The first foremost thing which has actually created important mobilization in this electricity utility is climate change, sustainability driven business transformation across industries, including electricity industry also. And if you see what is there on screen is that specific number that all of us, we keep on talking. That number is 1.5 degrees temperature rise. Now comes a question that actually how we got that benchmark number. Who decided at 1.5 degrees? So this decision of 1.5 degrees as a kind of a benchmark for rise in temperature is decided by Intergovernmental Climate Change Committee, where there is a participation of more than 60 countries and 140 researchers have done this statistical analysis of coming to this number, which is 1.5. And now what it says, if you see the trajectory, it tells you that today, if I do not act, what is going to happen to that particular 1.5 degrees rise? We actually don't want that 1.5 to reach. On the contrary, we want that 1.5 to get negated or to get subsided to zero. For that matter, obviously, we have to act. And that's why when we say that we have to act from India's perspective, what is the roadmap and what is the solution so that there will not be rise in temperature from electricity utility standpoint. So when we talk of an electricity generation, there are different types of fuels. There are different types of generating plants. Now, in this case, to be able to achieve this decarbonization, what is expected is to do energy transition. It means we really need to try hard in transitioning from conventional generation towards renewable. And that's one of the reasons, again, if we see the global benchmarking or global net zero targets, carbon neutrality targets, which are set by all these nations, the foundation is based on how much ready is that nation from technology point of view so that they can embrace renewable and they can try to offset the fuel, what is, you can call that as a fossil fuel based generation. And that's why statistically, as per India's outlook is concerned, we expect that within, from 2050 to 2070, we really want increase in renewable generation till or nearby 80%. However, to be really able to achieve this aim, objective, and say goal, we really expect accelerated scenario. Means irrespective of the possible percentage rise in the installation of renewable, we really want everybody to be aggressive. And that's why within just a span of 2050 to 2070, we really need to reach from 50% to 90%. So that reaching to 50% to 90% is really very aggressive requirement. And when we think from renewable point of view, it's a natural resource. So installations you can do, but how are you going to cater to optimizing natural resources? And here comes the role of digital interventions, use of all these latest technologies so that we will be able to achieve what we want to achieve. And the logic and the philosophy and the efforts which are applicable to Indian perspective, they are same applicable to global perspective also. It means everybody across globe very cautiously is undergoing two things, decarbonization and energy transition, with the same rigor and aggressiveness. And that's why coming back to where is the intervention possible? There is possibility of intervention primarily because of digitization. So like manufacturing industry, healthcare industry, electricity industry is also very much digitized. The meaning of digitized is that there is too much of penetration, very much thoughtfully done penetration in terms of having smart meters, smart analytics, SCADA system, monitor, command and control stations, etc. It means we are equipping our electricity legacy industry with the help of smart meters, and that's why there is digitization that's happening. Plus point of it is like now you are available with humongous data. Comes a question that how can you leverage that data for the betterment of improved accuracy, efficiency of all this. Okay, now this is another version of looking at how do we look in terms of electricity industry. Initially, a couple of decades before, it was a centralized utility, and now it is decentralized industry structure. Initially, it used to be a centralized digital capability. Now it is decentralized digital capability. It means that from various places, you need to collate data. And because of this decentralization, there are more and more opportunities of becoming more and more successful in terms of leveraging that data, taking up some sort of, or applying some analytics tools onto it, and will be able to do required, say, actions, will be able to perform required actions. So from generation standpoint, or say from government point of view, from companies point of view, they already know the, say, essence and the advantage of digitization. From customer point of view, interestingly, within 10 years down the line, we see tremendous change in the perception of customer, in the expectation of customer. Today, customer of electricity is treating electricity as a commodity, and that's why they are really very much demanding in terms of quality of power, security of power, reliability of power, continuity of power, etc., plus cost of power. Though it's not that way applicable to India today, however, globally, customer has that, say, privilege that today I can decide to take power from ABC company, and if I'm not happy with the performance of that particular company, I can immediately switch to other company. And that's kind of an element of competition you see across globe as per this industry is concerned. And this enablement of computation and enablement of competition is there because of digitization. It's a strong lever that has actually mobilized this particular industry. This slide is a kind of an outcome of Deloitte and McKinsey as well as Gartner studies on how are you going to compute all your actions in terms of cost of power and the price of power ultimately a customer is going to pay. So any decision that any utility is going to take in terms of decarbonization means penetrating more and more renewable, ultimately who is going to pay that money? Customer is going to pay that money. And that's why while taking any decision, you really need to have that techno-economical trade-off study, an optimization study done before taking up any responsibility and before taking up any, say, decision per se. This slide is a representation of what all is happening at distribution level of electricity value chain. Today, we see that there is solar PV installed at customers' home. So we have prosumers. They are called as prosumers. Categories of customer called as prosumer. Prosumer is the one who has got solar PV installed, so he himself generates. He consumes for his own load, as well as whatever excess is there, he has a capability to sell that to somebody else, provided there is a mechanism for that. Similarly, I own electric vehicle. Electric vehicle owner is a customer of electricity, plus is a kind of a support to grid because that electric vehicle has got a battery. So technically, a customer who has battery can support grid in terms of requirement of power and even can take power wherever there has to be a charging of the battery of that particular vehicle. It means the same customer has got dual role to pay. Now,
ନାଗେନ୍ଦ୍ର ତୁଷାର ମୁଁ ତୁଷାରକୁ ପଚାରି ଦେଖା ହେଇଥିଲା ତ ସାର୍ ମତେ ଇସ୍ୟୁ କିଛି ନାହିଁ କିନ୍ତୁ ମୁଁ ଖାଇବିନି ମୁଁ କହିଲି ସୋମବାର ଆସିବ ମତେ ଦେଖା ହବ ସେ କଣ ଲକ୍ ଅଛି ପଙ୍ଖା
No, that's fine. That's fine. Okay, fine. So coming back to the slide, what we see over here, we see different stakeholders. We see utility industry, we see transmission industry, we see distribution industry, we see customers, we see people who have electric vehicles, people who have solar power on their rooftop. And every stakeholder, every player has got tremendous amount of data that they can circulate amongst each other. Now, why there is a requirement of circulation of data amongst each other? It is same like if I have a solar PV, if I generate my own power, I consume my own power, but I have some extra power. Obviously, why not to sell that power to somebody who is in need of that power at certain price, which is negotiable amongst us. And I see that is the best use case for today's technology of discussion for this conference, which is blockchain, where you really need to have exchange of data and cross-leveraging of that particular data with all consensus known, keeping that transparency and trust. So that's a very impactful use case of blockchain for electricity utility. Some other interventions which we see preliminary, very dominant in electricity is load forecasting, demand forecasting, frequency forecasting, price forecasting, failure forecasting, etc., etc. It means making use of data analytics or making use of data that we get across multiple smart meters. We can develop analytical capabilities, which could be in terms of predictive analytics. It could be diagnostic analytics. It could be of the nature of prescriptive analytics, so that it will help utility to be able to actually make value out of that data and take some sort of an operational decision. So that this particular slide demonstrates how it is possible to leverage technical data, operational data, maintenance kind of data, asset specific data, and they do multiple kind of required insightful actions on it. I'll just skip this particular slide getting into detail. This again gives you an information of a digital infrastructure which is available now. Everything is available for me into my room, giving me a clear-cut visibility of number of transformers which are laid across the network. So thousands of kilometers of a spread of cable also I am able to trace from the command and control station, provided I do have those kind of IoTs and sensors deployed, and I do have those kind of smart meters deployed. Again, this kind of a digital infrastructure been seen at substation, and they are being seen at asset level. Asset means all those heavy equipments like generators, towers, substations, transformers, switch gears, etc., etc. And why we need this? We need this because all these equipments are live for 24/7. They operate for 24/7 with full load capacity. And then while functioning, there is always deterioration in the performance of that particular equipment. Somebody has to monitor. Utility needs to monitor health of equipment. And then all these digital interventions, they help utility to observe assets, monitor assets, understand the deterioration, and actually act on it before it fails. And that's why we use data analytics and AI ML capabilities specifically for health management, asset management, failure analytics. And the very good example of AR VR for all utilities, specifically in India, like say Adani or Tata Power, what they do, they train their engineers using AR and VR without actually touching and talking to the actual devices, but they train them using AR, VR, and digital twin to go ahead with scenario modeling, give them an actual feel of what kind of maintenance is required to be done for any switch gear, any transformer, or whenever they walk through any substation, what kind of precautions are to be taken while doing any sort of maintenance or while doing any kind of a condition monitoring. So we do see a humongous amount of, say, usage of data analytics, AI, ML, IoT, somewhere blockchain. Now, this is just a representative picture of different kinds of infrastructural damages which happen to the infrastructure of electricity industry, where there are cables, there are towers, there are insulators, there are transformers, and such physical damage which happens because of, say, natural calamity, which happens because of heavy rain, which happens because of dust and all, they affect performance of equipment. And that's why here comes computer vision, here comes image analytics, and here comes intelligent image to be taken by drone. Biggest example of this is Adani. What they do have drones, and they do capture images across thousands of kilometers of a transmission line. And all these images, they get analyzed post-clicking in terms of understanding thermal runaway of these transmission lines, to understand which are those lines that are getting overloaded to the larger extent. Now, this slide is a kind of very, very important slide from utility transformation, which is much more driven by sustainability. Under sustainability and climate change, there is great amount of encouragement from policy makers, from government, so that there should be more and more visibility towards use of your material and recirculability of your material. So this becomes a very great business case for every segment of value chain of electricity. This is again a kind of a representative slide which gives you end-to-end idea of what comes under scope 1 emission, scope 2 emission, scope 3 emission, which is required for electrical industry. And this scope 1, scope 2, scope 3, every element of emission is expected to be calculated by thermal generating plants, hydro generating plants, transmission utility, distribution utility, because they are expected to be known to the world, and most importantly, they are to be addressed by utility. Again, here comes a kind of helping hand and a kind of a lever that will be provided by data and data analytics, and a kind of software getting generated based on the functional and a contextual knowledge of this industry. There is a very important term that we call as materiality aspect. Meaning of materiality aspect is, for every industry, what are those priority tasks which they have to focus on, they have to make investment into to be able to achieve all their goals and objectives. So for utility industry, a representative example that an industry who is there in renewable power generation, they have their materiality task around maximum generation, minimum price, maximum safety of equipment, maximum safety of people, minimum downtime, and upscaling and capacity building of the employee. Apart from these operational things, now every industry has to take care of environmental impact. It means by having renewable generator, in the sense wind parks, they are entitled for quantifying certain KPIs which are environmental specific, like change of land usage, the amount of water that they use, impact of wind turbines on the habitat of birds, on the habitat of insects, and seashore, all the wind parks which are near seashore. These companies, they have to compute impact of the noise of the blade on the life below aqua. And all these KPIs are all data-driven KPIs. So you need to first have those sensors, you need to collect that data, aggregate it, and then apply that logical analytics to come out with these KPIs and then see how can you offset it. So offsetting the impact is something which is mandatory, and for that matter, you really first need to compute it. This is very important slide, which is a kind of an India's initiative towards encouraging entrepreneurs who are developing their business capabilities using niche technologies like AI, ML, IoT, robotics, blockchain, specifically in the space of sustainability, including decarbonization, energy transition, and circular business. This MOU has been signed between IEEE and Transition Venture Capital. This is a very recent MOU which got signed when Dr. Saifur Rahman, who is an IEEE president, he was on India tour. And then it has been instrumental since July 2023. And the objective of this MOU is to actually reach out to engineering colleges and other technology institutions, talking to the graduating candidates to make them aware of the opportunities in this particular space, handhold them, and of course, if required, financially support them also. I feel proud that yes, I'm part of this particular core committee and trying to reach out to engineering colleges having their entrepreneur development cells. The second slide is something like being as a volunteer of IEEE has come up with its own role, that being a technology professional organization, this organization has responsibility towards combating climate change, towards supporting all the members across globe towards climate change. And then pertaining to this particular climate change committee, where I'm also part of that committee as core member, here we have come up with some sort of a operational manuals across globe, inviting industries, inviting academia, researchers to come take up a problem statement of impact of any industry that they belong to on climate change, and then develop such sort of case studies. IEEE is over there to fund all those case studies. And of course, all such sort of case studies and all such sort of roadmaps and vision and mission of IEEE will get represented at COP28 this year, which is happening in Dubai. Because since last year only IEEE started participating, or IEEE got invited by COP to be a kind of a representation of a technology professionals. So this is the second year of IEEE in contributing to COP28, coming up with the response of IEEE towards climate change. So this is a kind of a walkthrough or a kind of a marathon, you can say, okay, fine, that I had to run through because I didn't want Padmaja to just wait. Thank you very much for joining me. Thank you.
Thank you so much, ma'am, for the enlightening session on decarbonization. Okay. Okay. Now we have distinguished speaker for session 2, blockchain, the future of business, Dr. Padmaja Patwardhan Joshi. Dr. Padmada Padvardhan Joshi is working as Senior Director in Center for Development of Advanced Computing, CDAC, Mumbai. She has did her PhD from IIT Bombay. She has published various papers in reputed journal and conference paper. Ma'am, am I audible, ma'am?
Yes, yes, you are audible.
Ma'am, I'm making you host. Huh? Already, she is already. Ma'am,
Yes, sir.
Ma'am, please remove or keep away your mobile from the system. We are facing. Ma'am, are you there? Hello?
Unmute and one device. You can do.
Am I audible?
Yes, ma'am.
Yeah, okay.
You can continue.
Yeah. Thank you so much. And extremely sorry. First, I would like to apologize. I would have loved to be a participate in this in person. Unfortunately, due to other commitments, I could not join you in person. But still, I would like to share some of the work, what is happening currently at a national level, as well as some views of mine on blockchain and its future, especially use in different kind of businesses. All of us know that blockchain, what it is, what are the different properties of blockchain. So predominantly, we are using blockchain in all those applications where we would like to have tamper-resistant records of it, especially in the area of e-governance, where blockchain has been thought about is we do have certain assets, and those assets, we want that a tamper-resistant proof of it should be available. I'm consciously using the word tamper resistant instead of tamper proof because we still know that in blockchain there are certain cases where there is still a possibility of manipulating the data. So if I'm having certain data in the last block of the chain, I still have a possibility of manipulating it, and that's the reason why I'm currently calling it as a tamper resistant. Maybe we will be able to further secure our chains in such a way that in future we will be able to remove that resistant and say that it's a tamper-proof kind of a blockchain. Another area where we are consciously using blockchain or is being thought about is distributed consensus or participation. The biggest use of it, what started blockchain itself, was Bitcoin. So in cryptocurrencies, we have seen that there is completely, because of the distributedness and because of the distributed consensus, different nodes are able to participate in the decision making, and that's where we can see the use of blockchain predominantly. And third and important one is no double spending. So here we have also seen the use of it in certain applications like e-voting, which is not even thought of that, okay, I can do e-voting and still ensure that whatever votes have been voted by the voters, it will not be impacted at all. Because firstly, nobody will be able to tamper those kind of votes. And secondly, I will not be able to vote multiple times. So these are the major properties for which we see that blockchain is being predominantly thought of, used in the applications. I will also talk about certain applications in this talk. While we are addressing all these, or while we are considering blockchain as one of the possible solutions in multiple scenarios, there are certain challenges because we still see that majority of the blockchain applications are currently either those are considered as POCs or a small demo kind of applications. very few applications of blockchain are available in production as of now. And the reason behind them is basically scalability of the blockchain. Many of the platforms that we are using to build blockchain applications, they do face still performance issues. Some of the startups are trying to overcome these kind of performance issues in specific frameworks, such as we know that Hyperledger Fabric, okay, which is comparative open source, and earlier days we used to face a lot of issues in multiple number of applications or concurrency in Fabric. But today we see that it has improved drastically. And slowly, I'm hoping that the way we are having currently our legacy applications or normal applications where there is no concurrency issue at all, blockchain will also be going in that direction. But as of now, to put blockchain into a production environment, that is another challenge what we are facing. Thirdly, though we say that, okay, blockchain can be used to secure or tamper-proof manner to record our assets or any transactions that are happening, it is still having certain kind of privacy and security issues. Basically because the pseudo-anonymity that we are maintaining about the nodes, so we will not be able to track a person if he or she is doing any kind of transactions in physical manner. So we are trying to identify a person with the address, but not as an actual person. So that is another challenge, especially when we want to use it into e-governance. That is the challenge which has been faced, because in e-governance, for every application, we would like to identify certain benefits or certain transaction, who has done it, who has got those kind of benefits. So if I'm having a pseudo-anonymity in blockchain, it becomes a little difficult to identify that kind of a person if it's a public kind of a blockchain where every node is doing that kind of transaction. And that's the reason why you can see that currently, whatever applications, especially in the e-governance domain we are thinking about, are more of a private blockchains and not the public ones. Okay, so these are the current challenges and properties of blockchain that I wanted to discuss with you. Now, looking at these properties, obviously, these are certain applications where we see that blockchain is being used. Firstly, is unique asset tracking. We saw that initially a lot of property registrations had happened as a POC of blockchain, especially in e-governance domain. The reason is property is a unique asset. Whenever we are selling, we would like to have the assurance that this property is not sold multiple times. So whenever we are having this kind of a tamper-resistant record of it into a blockchain, we are also trying to ensure that there is no double spending, which means suppose that today I am having a certain property, which I, let's say, sold it to person A, and then I'm a cheater, I would like to sell it to another person B. Okay, in current scenario, we will be able to actually sell it, but if we are having blockchain, we will be able to restrict this kind of a multiple selling of the single asset over here. So that is one of the major use case of blockchain, which we can see as unique asset tracking as such. And actually, the same thing is happening in supply chain management. In supply chain management also, what we try to identify is each and every asset that starts from its origin, how it reaches to its destination. So every asset is being considered as a unique asset, and we do complete traceability of it. That is where exactly the use case of supply chain management in the agriculture domain, where we see that many times farmers are saying that, okay, I have got these seeds, but I'm not able to get a good yield of crops. Here we will be able to bring the traceability between which kind of seeds are not yielding into the crops and who has sold those kind of seeds. So here the supply chain management blockchain will be really useful. Another use case which we can see in medical domain, wherever we are having some kind of medicines going from one location to another, we can even trace their validity. Is any kind of a pharmaceutical industry or chemist is trying to sell any outdated medicines or what these medicines contain. So including what a medicine should contain to Are we selling the right kind of medicines? All this can get tracked in supply chain management. Still, none of these have been come into production, but this has a great potential in bringing it into the production, because so far we have seen that major supply chain management that has taken place is mainly Walmart, where it has been proven that in such a large industry also it's feasible to track, and there had been certain use cases or certain POCs done at state levels. Especially I have seen in Maharashtra the agricultural domain for the traceability. Even in Telangana they have tried out if the seeds we can trace it, how it is going till the farmer, so that we will be able to give justice to the farmers. So that is what is the unique asset tracing is happening. The similar one which I was discussing earlier also, when I said that double spending, e-voting can be another example. In e-voting, I would like to just give you a brief about, because this was the project what we had done in Telangana. CDAC was the implementation agency, and of course the challenges are not only solved by blockchain in case of e-voting, but all of us know that there are major challenges of voting. Is if I vote, how will we ensure that my vote is not going to get manipulated? That is the first aspect. And second aspect of it is I am not going to vote multiple times. These are the two considerations which can be resolved, or these can be two concerns which can be resolved by blockchain. Of course, there are other problems, like whenever I am voting, how will you ensure that I am the same person who should be voting? Also, how will you ensure that, okay, I am not at a gunpoint whenever I am voting? So these are not solved by blockchain, but still emerging technologies. As earlier we have seen that in the presentation, there are multiple emerging technologies where AR, VR and AI are used. Here the facial recognition, where we can do through the liveness detection, or a new research which can come up that we can find out depending upon the temperature or of a person's face, or maybe some kind of a emotion analysis through a face, where AI can be used. We will be able to identify that the person is not under a gunpoint while he is voting, but that's a different aspect. Here in the blockchain, what we had done is every user or every voter who is going to be voting is being stored in the blockchain. So we know that who are the voters who are going to vote. Secondly, all the candidate information itself is again on the blockchain. So no additional candidate can come into the ballot. These ballots, what we are generating, are again very well protected. I will not disclose the technique which has been used over in the protection of ballots, because it's not blockchain. But yes, those ballots are also stored into the blockchain. And most importantly, whenever a voter is voting to someone, that vote is going into a blockchain. And here we have used a fabric blockchain where every constituency can have a separate channel altogether. And that vote goes into that constituency's channel. Once voted, if I try to vote again from my smartphone or wherever I am, okay, obviously it will be detected, because every time we are checking if this particular voter has already voted. But the beauty of this particular design is, important aspect is nobody should be able to find out whom the voter has voted. This, though directly, is not solvable by blockchain, but as the software designers or the system designers, we have taken care that there is no traceability possible from a vote to a voter. And now once the voting has actually stored into the chain, it gets only at the time of counting. And only the person, that is the RO, who is the election commission officer, only will be able to bring these kind of votes. So here, if there was no blockchain, this whole task would have been very difficult. So the property of blockchain, especially tamper resistanceness, where we are using hashing concepts and the hash chain concept. And secondly, the double spending, where we will be able to check only through a blockchain that if a particular voter has voted or not. That is helping, especially in e-voting. And I'm really happy to say that this voting what we have done, a proof of concept. It was tried out in a Khammam district's municipal corporation election, and it was successfully demonstrated that this is feasible. So blockchain can solve certain problems, yes, and it's a useful technology in addressing certain concerns. Another concern which all of educational institutions, of course, know about it, because most of the educational certificates today are stored in blockchain, right? I know that, okay, we all of us have heard the news about IIT Kanpur have developed the certification storage for all the educational certificates which are getting generated from that institution. I would also like to give one more example of certificate verification or certificate storage into blockchain. And it's an interesting one. I have told it in multiple blockchain related conferences also. We developed one application called as domicile certificate verification for Jammu Kashmir. And the reason was that when Jammu Kashmir started giving domicile certificates to its citizens, government was giving these kind of domicile certificates, but at the same time, there were certain private kiosks which were developing these kind of fake certificates and giving it to the citizens. Now, obviously, citizen is not aware of that there are fake certificates. And if they are aware, how will they find out? So what we did is, whatever are the certificates generated through the authentic channel, all these certificates were made available on the blockchain, and citizens can just verify that is the certificate received by them is authentic or fake. And if, again, I'll proudly say that blockchain is the useful concept over here, because if it wasn't blockchain, that data, what we are storing of domicile certificates could have been manipulated. But because it's a blockchain, we are able to say that we cannot manipulate the data and you are able to verify the certificates. So that is the biggest application of certificates which can be used everywhere. So today, wherever we are using kind of a cryptography to secure every certificate, in addition to that cryptography, if we are storing them into the blockchain, we can 100% be assured that the certificates are real ones. Now, once I have explained this, many of you can start thinking about its further usage. I can see that tomorrow, if we are able to generate some the signatures of the malwares, okay, if you could identify what those are, you will be able to use that by storing them in the blockchain in even cyber security domain. Or you can think of all those valid applications or something. If we are having those valid applications.
Sorry to interrupt you, ma'am.
Yeah.
Can we have another session?
Can you talk a little louder? I'm not able to hear.
Hello? Am I audible?
Yeah, you are.
Please conclude.
Okay. Just give me 2 minutes.
Okay.
Yeah. Or there is another example of it, which is still under trials, which is called as self-sovereign identity. That is another very important use case and will be useful in India. Of course, cryptocurrency is the one. However, there is not a specific point taken yet. And of course, there are lots of startups working in this domain, especially for the cryptocurrency or tokenization aspects of it. Okay. Here are certain possibilities of different blockchain applications. We know all that developing blockchain application has a lot of requirements. You have to go through consensus, you have to build the smart contracts properly, ensure that it is getting validated properly, and at the same time, we want to have different platforms. The complete network creation in those platforms is challenging. Very important application which has come up, even we have developed for India. At the same time, I know certain startups like Settlement and Spydra, all these they are developing is low-code, no-code kind of a platform for the developers of blockchain, so that they will be able to generate the blockchain applications much faster and good ones. Okay. Interoperability is another important challenge. It's still partially addressed, we can say, but that is another domain where research is happening and there is a lot to contribute over here. Applications we all know. Okay. In future, again, we will also have to think that today we are able to validate the things with the help of blockchains. But will that kind of a validation be possible even in the quantum era? And so in future, we also might have to think about the quantum sustainability of blockchain applications. As we are thinking about quantum sustainability, where the compute intensive things will be there, exactly opposite to that, tomorrow, if I want to have all the public blockchains, then will the low computing devices like mobile phones or something will also be able to contribute to blockchain? That will be the next step or next possibility of research work in blockchain. Of course, tokenization services can become like add-on services in any of the blockchains wherever required, the way today normal applications are running. Web 3.0, and as blockchain is evolving better and better, what we need to work upon is the standardizations and policies of it. I will skip this slide. Actually, this slide is about the National Blockchain Framework. This is getting developed, and very soon, hoping that in a month or two, we will be launching this so that you will be able to take advantage of this. This also has certain use cases. Okay, this is the portal for blockchain, and I will request that if you are a new researcher or if you are even a startup, if you have something additional, please feel free to contact us so that we can put your data. This should be a consolidated blockchain portal so that all blockchain developers, workers, researchers will be able to contribute over here and will be able to see the data at only single place. Okay, this is what we have also developed under the National Blockchain Framework. As I was discussing, it's a low code, no code kind of a platform where different kind of smart contracts are available for different types of applications. Those templates you can directly use by putting up your code into it, and certain code is already available. So 80% of the things are available as a template for you, and you can make use of this to develop your own application. Okay, this is just the form where I'm requesting all of you can send your information, success stories, startup informations, everything, and we would like to publish this onto the National Blockchain Framework. Thank you. I hope I have completed this within time. I'll stop sharing my screen. Yeah.
Thank you so much, ma'am, for enlightening session on how we can harness the blockchain in day-to-day life of human. Thank you so much.
Thank you.
I'm extremely sorry that I interrupted you.
No issue, I can understand. That's okay. Yeah, thanks.
Thank you so much.
Thanks. Yeah.
Okay, now we have paper presentation session. Next, I would like to hand over to my fellow researcher, Anil Yural. Over to you. Oh, sorry, it will continue. All the paper presenters have joined in this. Okay. Okay. Oh, thank you so much, all the participants present online and offline. And thank you so much, Director Sir, to join here, and distinguished dignitary to joining here for keynote talk given by Dr. Padmaja Joshi ma'am and Dr. Surekha Deshmukh ma'am. I once again thank you all on the behalf of ICBDS 2023 for joining here. Thank you so much.
I am checking now. Pen drive रखने के लिए ये किया। Okay. एक नहीं ऐसा पूरा पैक है वो माउस दे देना मुझे
हाँ उसके बगैर नहीं
हाँ
ब्लूटूथ
अच्छा 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 अभी निकाल
कर लो ना लैपटॉप से
हाँ ठीक है मैं देखता हूँ यस सर वील बी विजिबल
नीचे स्टार्ट वीडियो कर रहे हैं
तो प्रेजेंटेशन कर रहा है थोड़ा इसमें डेस्कटॉप निकालना है यस यस मैम
स्टार्ट वीडियो करना है
इसके अंदर हाँ नहीं लाइव चेक
हाँ अब
आप कहिए ना पहले हाँ ठीक है सर
ठीक
and just make sure all participants are available. Next time minimizing the top. Technical? I can.
इधर जूम में जाके वीडियो करना स्टार्ट वीडियो कैमरा मैं यहाँ सर के साथ ठीक है और कहीं प्रॉब्लम होगी तो कॉल करना
4 पेपर है ना बस सर यहाँ तक वहाँ जाता है हाँ
नहीं मैडम
नहीं एक मिनट एडजस्ट करेंगे ना कैमरा
हाँ यहाँ से वो आपको अपडेट दिखेगा ना
हाँ and welcome you to the IEEE CBDS conference. I hope all the participants are available. To make sure, I'm just asking you, whoever are present, recording. May I know Momin Islam? Jani, what is your paper ID?
127.
Oh, okay, thank you. And the rest of the papers authors are there? 230. Physically. Yeah, we'll start. Formal, I would like to start this session by introducing the session chairs for this particular tag. We have two session chairs. I would like to introduce session chair for this particular conference, Dr. Avantika Singh. Dr. Singh is highly accomplished academician and a researcher in the field of data science and artificial intelligence. Dr. Avantika Singh currently holds the position of assistant professor in data science and artificial intelligence discipline. She brings a wealth of knowledge and experience to our conference, having previously served as an assistant professor at IIIT Dharwad and IIIT Pune. Her journey has been marked by excellence with a PhD from the School of Computing at IIT Mandi. She holds a BTech degree from Uttar Pradesh Technical University, Lucknow, and an MTech degree from MIT University, Noida. Dr. Singh's research interests span a wide range of topics within the realm of AI and data science. Her primary focus areas include biometrics, machine learning, deep learning, reinforcement learning, and indexing and hashing. Her dedication to these fields is evident through her substantial contributions. In addition to her research contributions, Dr. Singh's teaching and mentorship have influenced and inspired many budding data scientists and AI enthusiasts. Her commitment to educating the next generation of researchers and professionals is commendable. We are fortunate to have her as our session chair, and I'm confident that her insights and guidance will enhance the quality of our conference sessions. Thank you, ma'am. And also, I would like to introduce Dr. Suhas Gajanan Sapati. He's a highly accomplished computer scientist with a rich academic and research background spanning over 2 decades. He currently holds the position of Vice Principal, Sanjeevan Engineering and Technology Institute, Panhala. Dr. Sapati's journey in academia and research has been remarked by notable achievements and significant contributions to various domains within the computer science field. Sapate's scholarly endeavors are characterized by a prolific publication record. He has authored numerous research papers published in reputable international journals and conferences. Notably, his research paper titled Radiomics-Based Detection and Characterization of Suspicious Lesions on Full Field Digital Mammograms was published in Elsevier's prestigious Computer Methods and Programs in Biomedicine with an impressive impact factor of 7 and CITE score of 10.1. Dr. Sapate is active member of several professional bodies, including IEEE Computer Society, IST, CSI, ACEE, IACSIT, IAENG, and ITES. As an expert in his field, Dr. Sapate has delivered numerous expert talks and presentations on various topics, including digital image processing and emerging trends in information technology. These engagements not only highlight his proficiency in communicating complex ideas, but also reflect his dedication to sharing knowledge and advancing the field. His work continues to shape and advance the field, leaving a lasting impact on both academia and industry. We welcome you, sir. Thank you for chairing this particular session. And now I request the first author, paper ID 230. Please. And one more information that each presenter is given presentation time of 8 minutes and 5 minutes of Q&A. So I request all the authors to restrict and follow your presentation to this particular timing. 8 minutes of presentation and 5 minutes of Q&A. We should share. Share screen. PPT open. PPT open. Full screen. Yes.
Yeah, good evening to all. So myself Chirag Modi, and I'm presenting our work on mnemonic spread management and SIM-based two-factor authentication mechanism for mobile wallets in blockchain. Actually, generally now blockchain access is growing towards the mobile wallets. And the main issue is that in wallet keys are generated based on the mnemonics in Bitcoin improvement proposal by 32. So there is like single factor authentication. Just to improve the security of wallets, we are presenting the two-factor authentication, and we are using the different cryptographic techniques for this. So our objective is to design a framework which can provide the two-factor authentication for the mobile wallets and key management for the blockchain while preventing the various attacks on the mobile wallets. So we are involving the mobile SIM card as an hardware component and mnemonic phrase to achieve the two-factor authentication. We are also applying the Summit secret sharing scheme in order to enhance the wallet security and robustness. And at the end, we are performing the security analysis of the proposed architecture by considering the different attacks on the mobile wallet. And as per our analysis, we found that the proposed architecture can prevent the different attacks on blockchain mobile wallet. So till date, there is no standard definition of the blockchain, but blockchain can be considered as a like distributed database, which is practically immutable, which is maintained by the decentralized peer-to-peer network using consensus mechanism, cryptography, and back referencing of blocks to order and validate the transaction. And blockchain has grown for various IT businesses and financial applications. So blockchain with mobile devices can give the improved security, transparency, privacy, and the user's convenience. So digital wallets are now being used for accessing the blockchain. So existing wallets are like custodial wallet and non-custodial wallet. In custodial wallet, keys and assets are being managed by the third-party service provider. So whenever some third-party service provider are managing my keys, there will be always a issue of the security and trust. So these are the examples of the custodial wallets. In non-custodial wallet, user has to maintain their own keys and assets. But that is not that much convenience for the non-technical user to manage their own keys. So to address the problems of both the wallets, we are we are proposing the combination of custodial as well as the non-custodial wallets, and we are trying to leverage the advantages of both the types of wallets. So this is the technical background where we are using the Bitcoin Improvement Proposal Standard 39, 32. 39 is for generating the mnemonics based on the seed value. 32 and 44 are generating the hierarchical digital wallets. We are using the NIST definer, password-based key derivation function, then submit secret sharing scheme. We are using the mobile SIM card as a secure storage for storing the one of the share. And then store device, we are using the hardware component for securing the some keys. So for that, we are using the Android Key Store API. So these are the examples in Android Key Store API, like trusted execution environment and secure element, which are securely storing the cryptographic keys. So this is the architecture of proposed framework, where mainly three entities are there. One is user's mobile, that itself is a device, SIM card, and one central server. We are putting certain assumptions, and these assumptions should be considered that at least 2 out of 3 entities should be always available for accessing the blockchain. And these are the functionalities we have created, like user registration for key generation and distribution of the shares, key derivation for blockchain access, key recovery, and password change. In current blockchain wallets, there is no mechanism of key recovery, and the password, if you are losing password, you can lose all your assets. So that mechanism we are also considering by applying the submit secret sharing scheme. So this is the one of the algorithm in which whenever you are installing the wallet itself is generating the 1 salt value. Then we are applying the bit 39 algorithm for generating the mnemonics. Then system is generating the 256 random number. This random number is serving as a second factor authentication that I will explain. And by using this, we are generating the one of the key, that is the encryption key, in which user's password salt value will be applied. This key will be used for encrypting the different shares. Now the shares will be generated from the given mnemonic value. So for that, we are using the submit secret sharing scheme with 2 out of 3 values. So to reconstruct the original secret mnemonics, that is MN, we require at least 2 shares out of 3 shares. So first of all, we are generating the shares S1, S2, S3, and PFA is the random number generated from the device. All these shares will be encrypted using the generated key. Now S1 and S2, S1 will be stored into the mobile's hardware storage, that is the key store API, and S2 will be stored into the SIM. As well as with SIM, we are storing the PFA value and the salt value. That means my SIM will store one of the share S1 salt value and this random number PFA. My mobile device will store the S2, whereas encrypted S3 will be stored into the central server. So like these 3 shares are distributed among these 3 entities. When I want to access the blockchain, I'll require the mnemonics. So to derive the mnemonics, at least 2 shares I will require. So these 2 shares I can take from the SIM card and one from my device itself. So first I will fetch the salt value password that already user knows. This data I will collect from my device itself. Then S2 share I will collect from my SIM. By using these 2 shares, first these shares will be decrypted and then they will be verified by comparing their S value. After the verification of these shares, the original mnemonics value is derived by using the Lagrange interpolation, that is the method in the submit secret sharing scheme. Once the mnemonics is available, then we can apply BIP 32 and 44 algorithm for creating the further keys. So here salt value is PFA as a salt, which is acting as a second factor of authentication. And once I am having the mnemonics, these 2 algorithms will generate the public-private key pairs, where public key will be used for reading the data and accessing the asset, while private key will be used for performing the transactions on the blockchain. So this is the another. Suppose there is a issue with the second system storage. Suppose my one of these share is corrupted or it is not available. So in this case, two sets are already available. One is with the SIM card, one is with the central. So I will collect, I will again regenerate the another share for that secondary storage, or we can say that key store API. And then again, I will encrypt it and I can store it again. So I like this, I can update my shares. Suppose I want to change my password. So to change the password, first of all, I have to retrieve all my shares. I'll create new key using the new password PADS. I'll create that new key. Again, I will encrypt those all the shares using the new key. And then again, I will overwrite those shares into those storage. So this is how you can change the password. You can recover your mnemonics, that is your key, which is not available in current algorithms or current Bitcoin based wallets. So security analysis is that here we are using the 32-bit 32 character long password and 128-bit salt. So ultimately, to perform the brute force attack, adversary has to apply 2 raised to 384 operations. Again, this to derive the encryption key, the adversary has to apply password on this niche defined function. So that is again in posing the additional delay to the attacker attempt. So that is difficult to perform brute force attack in this proposed architecture. Man in the middle attack is also difficult because here we are applying the system calls between the device as well as the SIM to fetch the data. So this will be prevented by applying the hash function. So even though if adversary is modifying the data, but at the end hash comparison is taking and that is why this adversary will not be successful. Man in the middle attack between center server and mobile app, even though adversary taking the encrypted share value, but that share value will be verified at the device using the hash. So even though adversary is getting the data, but this data will not be useful for an adversary. Dictionary attack is also not possible because even though adversary is guessing the password or is matching the password, but with password salt value is creating the difficulty for an adversary. Keylogger, with keylogger adversary can get the password. Salt value adversary cannot get from the SIM card because SIM is pin protected. So adversary require this salt value as well as password to break this architecture, which is very difficult. DOS attack is also not possible because of salt value. So in conclusion, I can say that here we are providing the two-factor authentication instead of single factor. And here the thing is that it is taking the features of custodial wallet as well as the non-custodial wallet. And central server is used only for updating the password and storing the third share. While for accessing the blockchain will require the two shares, which is available with my device. So it is kind of one of the kind of like custodial wallet. To change the password, I will take the service of third-party server. And submit secret sharing scheme is helping to manage the mnemonics securely. So we can say that security analysis is very encouraging to make blockchain access on mobile device secure and trusted. In further, it can be improved because most of the computation is happening at the mobile device level. That will reduce in future. So these are the references of our work. Thank you. If you have any question.
Now the floor is open for Q&A.
The experiments that you have performed is only to analyze whether these attacks are possible.
Because this is like security protocol, which we have implemented with NIT Goa chain. So for that, we have created digital wallet, and this is like security protocol. So compared to the implementation, this analysis, theoretical analysis was most important. So obviously in security domain, we are going more towards the security analysis compared to the implementation side. So this blockchain wallet app is created and that is integrated with NIT Goa chain, but it is difficult to observe what attacks and security. So that security proof we can give by using the theoretical analysis.
What ground you say that no such or whatever 5 types you have mentioned are possible?
See, one thing is that
of these 5 attacks is possible.
that is what I have proven with security analysis. As the key we are using AES key. For that, we are using the 128-bit salt value and password is 32-bit. So if I want to perform the like brute force attack, suppose I have to perform all the possible combination. Now to perform the combination, I'll require this much I'll require a total number of possible keys will be 2 raised to 384, which is very difficult. That is already proven by the AES. Okay. Second thing is that after getting this key value, we are applying this password and salt value to the what password based key derivation function that is defined by NIST. Again, that is creating the complexity for an attacker. So with current computing power, it is difficult to break it. But if tomorrow if quantum computers will come, that can be even in blockchain also, it is using the elliptic curve cryptography. That is currently correct, which is providing enough security. But if tomorrow quantum computers will be coming, it will be broken. So as of now, this system is secure, we can say. Denial of service attack. Yeah. So in DOS attack, what an adversary can do, he will try to make that server unavailable. But we are not having access, we are not using server for accessing the blockchain. The server is used only for updating the password as well as for updating the key. So the frequent access to server is removed, unlike custodial wallet. In custodial wallet, the problem is what? Whenever I want to access the help of server. So in that case, DOS attack will affect to the user. But in our case, DOS attack will not affect to the user. It will not affect for blockchain access. And password update is not that much frequent. So DOS attack will have the particular time period. It will not run for entire day or entire month. So suppose if I am not able to my password today, tomorrow I can do. But it will not take my credentials. And blockchain access I'm doing with my device only. Yes.
So can you elaborate some of the limitations of
Semi-secret scheme?
There are some of the limitations of this.
We are using the polynomial based semi-secret sharing scheme. In that case, if two persons are not submitting their shares properly, in that case it will get failed. That is the one of the limitations where it is difficult to identify the cheaters. But here both the shares are going to be stored in the secure storage within my mobile device. So there is not a question of like cheaters who are submitting the wrong shares. Another thing, like in verifiable secret sharing scheme, the users are verifying their own shares. But here what is happening? The device itself is generating share. It is storing two shares within my system. One share is going to be stored on the central server. So there is no need to verify also because it is within the system.
Your system is hacked or something like that, then what will happen?
But when my shares are going to be stored, one share is going to be stored into the SIM card, which is PIN protected. So even though if I'm losing my SIM card, suppose somebody is taking my SIM card, you will not be able to access my SIM card because it is PIN protected. Second thing is the key store API, which is also hardware-based secure storage. So even though my system is hacked, because this question is coming from forensic side also, if they are taking such device, they can get all the information. But with this security device, forensic people are also facing this problem. Thank you.
Thank you. The next paper ID is 143.
Yes, sir. Yes, sir. Am I audible?
Yeah, you are audible.
Shall I share my screen, sir?
नहीं, आप छोड़ दो वहाँ पे. You please wait. Okay, we should make you co-host. Then only you'll be able to present.
Okay, sir.
This current screen should be stopped for second. Hello, paper number 143.
Yes, sir.
Yeah, now you can share your screen.
Okay, okay, sir. Is it visible, sir?
Yeah, it is coming.
Okay, sir. Good evening to one and all. My name is Pradeep Kamboj, and I'm a research scholar at the Department of Computer Science and Engineering, Delhi Technological University, New Delhi. Today I'm going to present my paper titled Measuring and Mitigating Gender Bias in Contextualized Word Embedding. Okay, so deep learning models like transformers revolutionize the execution of automated tasks. However, these models are prone to many biases that can be perpetuate societal inequalities. Sometimes disclosure of gender information by these models may lead to privacy related issues. So these models are exploited most for natural language processing tasks and attracted the attention of researchers. So in this paper, we devise a post-processing mechanism that measures and mitigated gender bias in the contextualized embedding of the T5 models. So that is a text-to-text transformer model. So privacy offer protection against the gender-based violence, discrimination, and other harms that disproportionately affect women, intersex, and non-binary gender individuals. Nowadays, many decisions are made using these predictive models built on historical data. Then penetration of machine learning technology may lead to discrimination, biasing, and even if the computing process is fair, even if the computing process is fair and well-intentioned, but may still affect the certain societal group individual in adverse manner. So these are some of the examples where ill treatment can be done to individuals or some set of group of peoples, like automated hiring system or a compass algorithm that is used in US court system, and the denial of loan. These are this is the schematic diagram to show the various methods of mitigating societal biases or any biases from the model. So it can be classified into three categories. One is this pre-processing technique, where the transformation is performed on the original data, and then the fair results can be classified from it. Then in processing techniques, where some transformation is done on the learning algorithm in the loss functions or regularization to make the fair model that produce the fair results. And the third one, it comes under this post-processing technique, where the transformation is done on the embeddings generated by the model to produce the fair results. So, and the work here means our work is divided into two parts. So first, we provide a method to measure a gender bias in T5 model, contextualized word embeddings, and then we demonstrate how to reduce stereotypical gender connection with gender neutral employment. To quantify gender bias, we follow the approach of S. Katsarov et al. And measure gender polarity with respect to various professions in T5 contextualized word embeddings. So in this approach, stable gender direction is utilized to measure the gender polarity in the word embedding. So here this G is a stable gender direction in the vector space, like he and she are the vector calculated by taking the weighted average of all the sentences that contains he and she respectively. And this WI is embedding vector of professions words that is determined by calculating the weighted average of the embeddings of each sentence that contains the respective profession as a subject in it. So this is the data set that we've used is STSB data set, that is a semantic text similarity benchmark by Stanford. Now this STSB dataset, it contains a pair of sentences along with the scalar quantities that indicate the degree of correlation with them. So this is our methodology we use to mitigate the gender bias from the contextualized word embedding of T5 model. So here the idea that we used for mitigating the gender bias is that first we calculated the stable gender direction, and then we just project all the profession words orthogonal to that gender direction, so that the resulting vector do not contain any gender information in it. So the first algorithm is D-bias polarity to calculate this, to mitigate the gender bias, which further use algorithm 2 and 3 in it for calculating the orthogonal projection and for calculating the angle that is a polarity. So these are the results. So this 173 gender polarity values per profession of T5 large model. So here we can see that these the histograms that are in orange on the left side are for she vectors, and this on the right side blue is for he vectors. So they are symmetric from the center. So and all the others, these are like 8 professions that we have chosen, like nurse, engineer, surgeon, scientist, receptionist, programmer, teacher, homemaker. And from this we can see that some of the profession like homemaker, nurse, teachers, and these are lean towards the she polarity, and the profession like programmer and engineer, they are lean towards the he polarity. So it confirms the gender bias in it. So here in this we mitigate this we apply this algorithm 1, and this again, this is for T5 large. We computed this on 2 models, T5 large and T5 base. So T5 large, it produces the embedding vector of one size 1024, and T5 base, it generates the word vector embedding size of 768. So after applying algorithm 1, this is a result, and this is a T5 base again before applying our algorithm. Again, here we see the same results, and this one is again here also we observe the observe the same phenomenon as we see in T5 large model. The gender polarity distribution of the selected profession, it shifted towards the center, and hence it confirms the reduction of gender bias. So this table 1, it represents the correlation of profession word embeddings with the gender direction, and the values which are closer to 0 means which are scores in the bold case, it signify less similarity, and hence a less gender bias. So 3 exceptions are there in this, all with the T5 based model for profession like surgeon, programmer, and engineer. That can be justified, as in these cases, after applying devising technique, the result, it leaned towards the female gender, and hence the stereotypical myth that males are more likely to be associated with these professions is subsided. So here we provide a gender bias debiasing approach of T5 contextualized word embedding in this research. We first measure the gender bias in contextualized T5 models word embedding by taking the gender polarity distribution of gender neutral professions with a gender direction. The experiment result, it shows that the stable gender direction in contextualized word embedding can be used as a standard for evaluating gender prejudice. We observe that before devising the embedding, some of the gender neutral professions like nurse and homemaker, they are polarized towards the female gender, while the professions like engineer and programmer are polarized towards the male gender. So the result also shows that the gender polarity distribution of the profession words for projecting them orthogonal to the gender direction have less gender bias as they move towards the center of the gender polarity distribution. So for a future scope, the researcher can apply and observe the effectiveness of our model with other transformer-based models, including multilingual T5 models and others. So these are some of my references. Thank you.
Thank you, sir. Now the floor is open for questions.
Yes, please.
There was a standard database that you have used with, I hope, 173.
Yes, sir. So, sir, I will. So these are the 173 combinations of professions. We have chosen the sentence she is walking, or nurse is walking, he is walking, programmer is walking. So in this way we make the combination for each word, like he is walking, then for all these 8 profession we make receptionist is walking, then doctor is walking, programmer is walking, like this way. So we make these 173
my question
sentences.
Is, your analysis and the result is only on the given data set.
For that data set, yes, sir. STSB data set, sir.
Okay. So is there any other data set where the same kind of accuracy you can expect?
So it can be checked on, sir. I have not applied it on any other data set yet, but it can be done, sir.
What other applications you can use this mechanism to?
So this way only we can find out other social biases also, like racial bias or any other kind of bias also can be mitigated in the same way, sir.
Okay, but without checking, the application to the wide range of data sets, how can you say so?
Actually, sir, I extend extend the work of this one of the researcher. From in his work, he just find out let me show you, sir. So these are the results which he only proposed how he only measured the bias in that data set, in the T5 model. So these are the results of that author Katsarao. So I extended the work of his that I also mitigate the bias from that model.
You haven't compared your results with him, right? Only the
right.
You are not comparing it with. Like, have you got better results than them? Like, how much better? for extended someone work, then you have to compare it, right?
Right. So in this, I just from this I just shown that all these the embeddings are moving towards the center. The polarity is moving towards center, but this thing can be done. So here I have calculated the cosine similarity of all these. So again, they move towards zero, means towards center. It means they are less biased.
The question is why
Actually,
you have.
Yes, sir. I got your question, sir. You are asking why you have not compared with any other work, na? But sir, actually, the reason is that I didn't find the same kind of work done by any other author. So in that work, he only measured the bias. So I try to mitigate the bias also.
But you are telling only that Katsura has already made that contribution. And then now, what question is, what is your contribution apart from just extending the work? What is your own contribution in that?
Sir, my own contribution is that I also proposed a method to mitigate the gender bias from the T5 model, the embeddings of the T5 model.
So it was not proposed by Katsura?
No, sir. They have not proposed that. They only measure the gender bias.
Mitigation is not discussed in that paper.
No, sir. They have not discussed.
Okay.
Yeah, thank you, sir. Thank you for your time presentation. And next presenter.
Thank you, sir.
Next presenter will be 127. Paper ID 127.
Yes, sir. Am I audible, sir?
Yeah, you are audible.
So can I share my screen share?
Yeah.
Can you please ask him now to.
Sir, is it visible, sir?
Share.
Okay, now you can share.
1 minute, sir. Is it visible, sir?
Yes, it is coming.
Yes. Assalamu alaikum. Hello, everybody. Good evening. I am MD Mohammed Islam Johnny, and I am a student of Daffodil International University, Bangladesh. I am going to present a survey on shared perception, help-seeking patterns, and awareness of cyberbullying among the Bangladeshi citizens. And here is some co-authors. And sir, 1 minute, sir, please.
Please make your PPT full screen.
Sir.
Make it full screen.
Yes. So here's some presentation outline. Introduction, objective, motivation, methodology, and I am going to the introduction part. It is rightly said the last 10 years of IT have been about changing the way people work, and the next 10 years of the IT will be about transforming. There are very few people who have not been exposed to cyberbullying through various electronics, media, and other portals. According our data set, 60% of the 70% internet user in Bangladesh admit to cyberbullying. In Bangladesh, 11 to 17 years old are more affected by cyberbullying. We have created the data set on information sharing, perception, patterns, and awareness about cyberbullying, sir. We analyzed the data using Panda, Matplotlib, and Sterling. Actually, sir, actually we shared the paper of the main aims is to collect that the information sharing and the what they do think about the cyberbullying about the cyberbullying. Sir, here is the objective. The aims and the objective of this study are to find out the condition of cyberbullying case among different gender. What do they actually do when they faced it? What are they are thinking against this major crime? And therefore, we collect data from victims and non-victims also across gender and diverse the occupation. We discuss the sensitivity of both men and women to their infection and the sex-specific types and the resistance. And this is the motivation part of our slide. We developed this paper to highlight what can be done to remedy this problem and finding the exact case of cyberbullying and crime prevention and finding the specific way to solve for people with different behaviors. Here is the methodology part, and here we see the data working methods. We collect collect the data and data cleaning, data labeling, statistical analysis, and then decision analysis. And our study methodology is outlined in the figure. We collect the data set from different profession such as students, teachers, housewives, doctors via Google Form in online and email site. The data set was divided into 897 rows with 11 columns. 11 columns are 11 questionnaires. As our authors are from different districts of Bangladesh, so we have collected this data from most part of Bangladesh side. And here is the second proposed methodology, data cleaning. We found some blank values in data which we collected and clean the blank data, and zero column also holds them the mean value. And when data labeling, there were a mixture of English and Bangla language also. So then we labeled the data set by label encoder because some of options are so long for this reason. We convert those option of numeric form, and when we go to the statistical analysis. In statistical analysis, we defined hidden relationship with features by finding correlation of the attributes also by comparing features with the final output. And here is the statistical analysis. Statistical analysis was conducted on their perception of sharing and protecting personal information from social media or other site. In figure 1 here we see that show the comparison about gender and occupational response. Maximum response we received from women and students, and their percentage of students is 68% of 77% women, sir. And here is the part of figure in figure 2. We show the difference between acceptance of cyberbullying by gender. About 70% of female faced cyberbullying against the male. And here in the figure 3, we see that shared personal of information in different website on portals, sir. They faced cyberbullying maximum time and 24 to 33 and 34 to 43 ages range people shared more information in than others. And the figure 4 we shows that when we comparison between harm reporting and faced cyberbullying, we see that female are the most vulnerable to the cyberbullying field travel figure. In figure 5, we show that the comparison about the law and about the law versus cyberbullying on our data set, about 320 victims, 320 victims of cyberbullying said that there are not enough laws in place to deal with cyberbullying. And the fifth and the sixth figure, we see that the option of asks to help any other. We divided the major 4 points to help seeking percentage. 4 points we give in numeric value. 400 people said that asked help or try to solve this problem about their family and friend also. And here is the figure 7. Almost 300 or 50 victims and non-victims people suggest that train to protect the password and personal details online, providing counseling to discuss without hesitation one and any other. And result and discussion of this paper analyze analyzing and reviewing the data. We found that younger female students are the most victims of cyberbullying, and people who share more personal information in online are more susceptible to the cyberbullying also, and many of them are in great danger also and committed suicide. So many have asked family and friends for help and to develop a training system to avoid the cyberbullying. And in the conclusion part, we have shared the 3 parts: achievement, benefits, limitation, and the future scope. Being able to highlight the impact to help-seeking styles among female admitted to the cyberbullying, as well as discuss without hesitation in providing counseling and hotline support also. And the limitation is our virtually data collected and minimum data collection over the populous country. But the future scope to apply machine learning algorithms to predict the perfect rate, and analyze how administration interacts with the judicial process also, and investigate the underlying cause of cybercrime from both criminal victims' viewpoints, what they think and what they say. And we intend to work on this at the next time. And and here is the sum of reference. Thank you, sir.
Thank you. Now the floor is open for questions.
Yes, sir.
Yeah, apart from statistical analysis.
Yes, sir.
Any technical contribution?
Yes, sir. Technical contribution, yes, sir.
What is your technical contribution? Any
Sir,
towards technological development?
Sir, we collect the data in various site of various people, and the technical contribution is that we want to solve this problem to I think we are trying to solve this in technical part is to solve the problem in sharing any other personal information, and to stop and the cyber security also developed, and the judicial law also developed, and in this kind of problem, sir.
your representative data set is very low, like very less amount of like in Bangladesh, I guess population is more than 16 crore, right?
Yes, sir. Yes, ma'am.
Data is, I guess, 300 something samples you have taken, right?
Ma'am, 897 samples and 350 women's students are.
That is too low, right? Like
Yes, ma'am. That is so. Yes, ma'am. Minimum data collected in the populous country. Yes. We intend to try to next, ma'am, to collect maximum data.
Thank you. The next presenter in paper ID is 239.
Thank you, sir.
Thank you. Hello, paper ID 239. Hello, Aditya. Hello, paper ID 239.
Yes, sir.
Yeah.
Just a minute. My colleague is joining in a minute.
You already late.
Yes.
Days are waiting.
Yes, I'll share my screen.
So, and you have to remember that the presentation time is for strictly 8 minutes.
Okay.
And rest 5 minutes will be the Q&A.
Yeah, sure. Actually, it says that host disabled participant screen sharing.
Now you can share the screen.
Okay, I'll check. Yeah.
Is it coming?
Yeah, it's coming. I hope my screen is visible.
Yes, visible. You go ahead. Make it full screen.
Yeah. Just a minute. I'll call him immediately to join the session. We'll start.
You can start.
You can start. Actually, I said already.
Okay. Yeah. Okay, I'll start. No problem. Okay. So good evening, all. I'll just. Okay, so good evening all. The title of a paper is Enhancing Security, Privacy and Scalability in Blockchain and Internet of Things. It is a survey paper. We have studied various overview of the integration of blockchain and Internet of Things. So these are our authors, Aditya Moon, that is me, I am myself Aditya Moon, Shiva Mishra and Manisha Maniman. So abstract. So basically what we did was we actually delved into the integration and integration of blockchain and IoT. So blockchain, it is an open ledger which actually enhances the scalability, security and privacy of the Internet of Things. So moving on to the next slide, we can see the diagram over here, which represents that firstly it says that blockchain IoT hub, where we have actually done the integration. Then we have the optional gateways where there are a few FOG nodes that I'll explain later in this PPT. And then we have various IoT applications where we send the data through the block. So let's check the overview of the integration. So now we can see that the enhanced security and privacy, that is by leveraging blockchain consensus mechanism and encryption strategies. There is a data integration provenance, which is the immutability of the blockchain. As we know that the blockchain provides tremendous security, and it can't be changed. So we can easily integrate it with IoT, and we will have all its benefits. So next is the decentralization and belief, where the blockchain eliminates the want for the centralized authority that is a middleman. So it just eliminates that quality of the IoT. And lastly, we have the scalability and overall performance. As we know that blockchain can deal with massive volume of transaction and accommodate the growing quantity of the IoT gadgets. Next one, now let's see the use cases and applications. So firstly, we know that the supply chain and control traceability, the blockchain enables real-time monitoring of goods. It verifies the authenticity of the merchandise. So it is of a great help here. It can transform cities by integrating numerous systems such as transportation, power, waste management, and governance. Blockchain also enhances the security, privacy, and interpretability of the health records in IoT-enabled healthcare systems. Energy management and grid structures would be more efficient as it allows decentralized power management, improved grid efficiency. And lastly, in the agriculture and food industry, it allows actual time of tracking plants, farm animals, and garage situations. But as we know that the coin has two sides, so there are limitations and challenges as well for the integration. The inherent design of blockchain limits the number of transactions that can be processed per second. And as the range of IoT gadgets transaction increases, scalability can't be achieved after a point. It requires the development of standardized interfaces, making sure the seamless communication and managing the compatibility troubles. Now moving on to the next slide. We have the blockchain and IoT security. So as we have already established, the IoT devices have emerged the components of increasingly into the interconnected world. However, their vulnerability to cyber attacks, as we know, is of absence due to the various security mechanisms. And recently, in the first half of 2021, there was an attack, cyber attack, where 1.51 billion breaches was occurred in IoT security.
Sorry to interrupt you.
Yeah.
Like you have written the, I guess, notes. Now you are reading them.
Yeah.
Don't read them. Just explain. You have to complete it in 8 minutes, right?
Yeah.
Instead of you have written so much notes and you are reading it, we are able to see the notes because you have shared, right?
Yes.
Just explain
Sure.
in your own words instead of reading it.
Okay. Yes. I'll share. Just a minute.
Contribution.
Okay, so
discuss on your main contribution.
Your main contribution, or what are the challenges, or what would be the future aspect of blockchain? You can discuss that thing.
Yeah.
Too much papers for survey, right?
Right. Okay, so what we actually researched about, there were a few techniques for the protection that blockchain actually provides. So blockchain provides the processing of transactions, that is, as we saw in the limitations, there were some limitations for the transactions, but blockchain actually registers and interactions. It makes it more secure and transparent. The next technique is the tracking of data. As we know that blockchain gives it is an open ledger, and it gives every details to the customer, like it has on its website. So it can be tracked very easily. So privacy will be explained by Shivam.
Yes, so thank you so much, Aditya, for explaining the starting slides. So I'll be taking on from here. So blockchain and privacy. So in every
3 more minutes, you have to conclude your work in 3 minutes.
Okay, sir. Sure. I'll just brief up. So I'll just explain the diagram. So what basically this the diagram overview of privacy in blockchain means that the end user interacts with the IoT applications, the front end side, and then in the back end part, we are the main role is of IoT sensor that fetches data from the IoT sensor that fetches data. So blockchain plays an important role in acting as a secure layer for the same. And yeah, so next slide, please. Yeah. So the challenges for so I have divided the slide into two parts. So the challenges, and then after that I'm discussing the advantages, the positive parts. So the challenges for privacy in IoT. So there are two major challenges. First one would be coordination among devices. So basically in IoT devices, sometimes the data is collected between multiple sensors. So the extent of data is very large. So due to which the attack of different there are different cyber security issues that can arise. So this is the first challenge. Second would be sensors and blockchain. So the second challenge would be that due to the large number of sensors. So as mentioned by me earlier, so yeah, the due to the large number of sensors, so due to large number of sensors, the security is also security is also
in danger. So we can.
Yes, exactly. So next
Yeah.
one, blockchain and IoT scalability. So as we continue further, so the limitations of blockchain instances are as follows. So scalability and overhead. So a significant challenge in blockchain would be scalability. So the architecture can also lead to substantial scalability issues, as both broadcast traffic and processing overhead can grow exponentially with the number of nodes. So second one would be complex consensus algorithms. So due to complex algorithms and the computation power that they require to run, so it could also affect the time. It could also affect the scalability. Then we have latency. So due to the large applications, and for instance, due to large applications, we have latency issues also. Then throughput. So the throughput is primarily determined by the number of transactions. So when there are more transactions, so it also impacts the scalability. So database length, and then we also have privacy and guidelines. So strong transactions all from IoT devices can raise privacy concerns. So it can be either by the linkage of multiple transactions, or when the transaction is encrypted. So next one would be that the benefits of blockchain and IoT scalability. So the benefits would be it's lightweight, scalable blockchain. So we can develop a blockchain which is lightweight and scalable. So it is managed as mentioned in the slide. So the blockchain is managed by cluster heads to ensure scalability. So there are different. So we deployed different distributed systems, due to which the load is being balanced. So first one would be this one. Then second one would be memory optimized and flexible blockchain. So the mode of operations for blockchain.
You're almost time. Please conclude.
Yes.
Okay.
I'll quickly explain the diagram. So as I previously mentioned, the blockchain network serves as the intermediary between the user client and the data storage, as well as the IoT server. So whenever the IoT applications transmit data, it firstly goes into the FOG node. It is an intermediary node, and we have a sidechain running on FOG. We can take an example of Kubernetes or Docker for the sidechain, and then it transmits the data through the IoT server. The IoT server manages sends the data, and the blockchain network actually makes it more secure, and then the user or the client can view the data easily from the blockchain network. And this was our results and discussions. We carried out a literature survey of various papers and made a proper IoT, or we made the proper significance of each paper. So many of the papers signified various IoT applications. For example, smart grid, smart home IoT data sharing, as well as this is next slide, where secure cloud storage and IoT control access were shown. And these, so for concluding our research, we have discussed the integration of blockchain with IoT, and how the blockchain makes the IoT more secure and scalable. However, there are various challenges that that may be resolved in future. And yes, so these were our references which we used. So that was it. Thank you so much.
Thank you. Now the floor is open for questions.
Yeah.
Yeah. Thank you, Aditya, and thank you. I would like to thank all the authors for these presentations in this particular track, and I would like to thank the session chairs for their valuable time and constructive feedback to help the researchers to improve the quality of their paper and further also. And also like to thank the audience who are present and listened. And I would also like to thank the organizing team to take up this particular session. And with this, I'll be ending this particular session. Thank you.
Okay, thank you so much, sir. Thank you.
We'll be having one photo session. So please switch on your camera. If everyone has to switch on their camera. Participants, online. Yep. Pradeep, sir. Yes, sir. Sir. उनके साथ भी फोटो all session. ऑनलाइन मिक्स ना सर आप सर आइए सभी आप भी आओ सभी ये सफल सर थोड़ा आगे ऑनलाइन
All participants, smile please.
Thank you.
Okay, thank you.
Thank you. Thank you all.
Thank you, participants.
Now the session is over. You can disconnect if anyone has joined the meeting.
Thank you so much, sir. Thank you.
Thank you.
Thank you, sir.